I'm genuinely very excited for this course, and I will tell you why. Right. So let me start recording. So I will just start the recording.
Recording in progress.
Okay, great. So welcome again, everyone. So I'm very excited for this bootcamp, right? There are a couple of reasons why I'm excited. One is Spark is really something that you will love, right? Whoever has created Spark, right? They have created with so much love and passion, at least I feel, right? I'm not telling that it is a good technology, that's why, right? I'm telling because the way they have built it, the way they have provided the Spark UI, right? So we learn a lot of technologies, right? But under the hood, we don't know everything, right? There is something black box is always there. But in Spark, they provide so beautiful Spark UI. Every time you run any job, any code, you can literally see in UI what is happening, right? You would have never seen this. Whatever technology you have learned in past, you would have never seen this kind of thing that we will see with Spark, right? Whatever you are running, there is no black box. Literally, it is a X-ray. Spark UI is a X-ray. Whatever you run, literally you can see how data is flowing, how many partitions are there, how many stages are there, everything, the plan, the job plan, everything you can see, right? So it is, that's why I'm excited because I know how cool it is. And I'm excited that when you will know, you will also have the same reaction, right? So that is one thing. Second thing is I have been preparing for this bootcamp for around 2 months now, and I'm very confident, and I know that I will be teaching in a way that one of the best course it will be on the Spark, right? That's why I'm very excited for this bootcamp. Okay, great. So what we will do, so I'll tell you the agenda, what we are going to do today. And then I'll tell you few more things that you should follow throughout this bootcamp, and then we will start. So today's agenda will be, we will little bit go in the past and see that what is the evolution of big data technologies, right? Why there was a need of Spark, right? Why there was no other technology which could process data like Spark, right? So we'll just go back in history, learn about it, and once we have that intuition that why Spark is needed, right, then we will start learning Spark, right? We will also learn about what is distributed computing, right? You would have heard term distributed computing. So Spark is one of those technology, one of the first technology which did distributed computing, right? So we'll learn about what is distributed computing, what is the difference between monolithic and distributed systems. All of that we will learn, right? Now, before I start, I want to tell you a couple of things, right? One is once the session is over, you will have access to the recordings on the portal. I'll show you from where you can access. If you have done previous courses on Namaste SQL, then you know. But if it is your first course, I'll tell you from where you can access the recordings, right? So once the session is over, so timing, a lot of people are asking for timing. So timing is same, 11 a.m. IST, Saturday, Sunday. Every weekend, Saturday, Sunday, 11 a.m. IST, there is no change. If there is any change in particular day, you will get an email notification 2-3 days before only, right? So if I am not told anything, it is always 11 a.m. IST, Saturday, Sunday, right? That is one thing. Second thing is many of you are part of the Telegram community already, right? Some of you have not joined, right? So please join the community. Link is there in the course portal. I'll show you in a minute, right? And that is for offline discussion. Let's say someone is struggling to set up a Spark, right? Or someone has some question around whatever we learned, right? So you can ask questions, help each other. So that is for offline collaboration basically, right? So make sure you join the Telegram community, and that is for lifetime. It is not that after this bootcamp we will delete that. That will be there so that in future also you all can be together and discuss things related to Spark or any jobs related thing. You want job, someone else can help you in their company. So it is kind of community for you, right? So second thing is that. And the last thing I want to tell is uh, be consistent, right? So what happens is in every bootcamp, what I see, people will join live bootcamp initially, right? And then they will see, okay, recordings are available. I'll see the recordings later. And because of this later, they will keep pushing it, right? They will not learn it in one go, right? Now this will go to 5 to 6 weeks, right? So if you can focus 5 to 6 weeks, and maybe after boot camp another 2 3 weeks or a month, right? So then your spark will become solid. But if you do, okay, one class you are doing it now, then you are thinking, okay, I will check the recordings later, then you are just postponing it, then it will not work, right? Consistency is important for next 2 months. Okay, great. I think that's it from my side. Let me start sharing my screen. Okay. Okay. Hope my screen is visible.
Yes, Ankit, that's visible. Just disable the annotations, please.
Okay. Uh, okay. So you have to log into namastesql.com, right? Once you log in, you will be on this page. So you will go to my courses, right? You click on resume course. So we will have one folder for each day. So for example, day 1, day 2, day 3, day 4, day 5, kind of, right? And in within each folder, you will have recordings, right? And if we have to add any quiz, we will add quiz. And if there are any assignments or resources like I'm sharing some code or notes or files, everything related to day 1 or will be in that folder. Similarly for day 2, right? And after the session, within 2 hours, recordings will be uploaded and other materials also will be uploaded mostly, right? So you can access everything from here, right? So also let's say you have joined today's class, right? And you missed tomorrow's class. Now next week when you join the next class, make sure you complete the recordings, right? Because if you miss something, maybe in the third lecture I am referring to something which I covered in previous lecture, so you will not be able to understand it, right? So when you are coming to live class, make sure you covered all previous classes first, right? And then you can come in. Okay, great. So let me close this. And okay, so I have notes. I'll share. I will be sharing these notes on daily basis, right? Some of these notes are complete as and when we are going, and some of them I have to work on it, some topics, right? But I'm creating these notes so that I can also follow along with these notes, and I can share with you as well after the session, so that you can revise it, and for any purpose, if you need, you can use these notes. Okay, so now you are here to learn Spark, right? Now, you all know, right? If you don't know, then I'll tell you that Spark is a technology to work with big data, right? For big data processing, right? Ultimately, the USP of Spark is you can work with big data. Then this question obviously comes, what is big data, right? For someone, 10 GB data can be big data. For someone else, 50 GB data can be a big data. How you define the big data, that this is the big data and Spark will be a solution for this, right? So let's understand what is big data and what are the technologies that came and worked on these big data things, right? Okay, great. So this is the definition of big data, right? Big data refers to data sets that are too large, generated too fast, too complex or unstructured, right? Now, one more thing I want to tell you before we start, our most of the sessions will be practical sessions, right? I think today's session will have a little bit of theory. Otherwise, most of the sessions will be practical. I will be showing you something, or I will be creating some charts and explaining you, and then we can go through the notes, right? I'll not read these notes during the sessions except today, right? Maybe few things I will read, but it is not that thoroughly each line I'm reading, right? It is for you. I have created these notes for you, and I can also refer you that what is the next topic that I have to pick, right? So it will help me as well as help you. Okay. So when we say big data, there are three V's of big data, right? If these three things are there, we say it is a big data. First thing is volume, right? Large quantities of data generated from multiple sources. So you have huge data, right? Nowadays, if you see everywhere, if you take any example, for example, if you are watching YouTube videos, right? You think about it, every person is generating how much data, right? You watch a video, right? That is also getting stored somewhere that this person watched this video, right? For how many seconds you watched it, for how many minutes you watched it, did you like this video, right? If you have commented, what comment you have made, right? They have all the watch history, right? If you have enabled watch history, they will have all the watch history of your whatever you have watched, right? You can watch later, you have a lot of options, so they have to store huge amount of data, right? One person is generating so much data every day, right? Imagine they have millions and millions of users, right? So if you see YouTube, 500 hours uploaded every minute, right? So 500 hours of video content is getting uploaded every minute on YouTube. So you can imagine how much data they will have to store, right? Facebook, billions of messages, comments, and images daily. Netflix uses watch history and streaming logs, right? So they use watch history to tell you that what kind of movies you will like, right? So there's lot of data volume that is getting generated. That is one way of big data, right? Second V is velocity, speed at which data is generated and needs to be processed, right? The data is huge, but that is generated at a very fast speed, right? For example, stock price updates in millisecond, right? So every millisecond stock price changes are happening. Uber ride tracking and search price calculation in real time, right? So if you are, let's say, you are booking a ride on Uber, right? So they will see how much busy is, how many cabs are available, right? And that is real time, right? So it is very fast. They have to do the work, right? Payment fraud detection, right? Sometimes you are making payment, you will get that this can be a fraud, right? This is in real time, right? So we have huge volume of data, but we need also at very fast speed, right? We need to process that data at a high speed. It is not that I have huge data and I will take 2 days to process it, right? I have to process that data at very fast speed, right? So that is velocity. So we have volume and velocity, and third one is variety, right? So we have different kinds of data. One is typically that mostly we work with is structured data. We have SQL tables, or you work with Excel, or most of the tools that you work with are worked on structured data, right? SQL tables in tabular form, basically. Then we have semi-structured data, right? JSON, XML, logs. Then we have unstructured data. Unstructured means images, videos, right? They don't have a structure, right? In JSON also you have some structure. You have key value pairs. Similarly, in XML you have some structure. Logs also will be in particular structure. But these don't have any structure as such, right? PDFs, audio. So these are unstructured data. So these are three big V's. There are other V's also, but these are the most important three V's on which we define big data, that high volume with very high speed we need to process it, and we have different variety of data, right? Awesome. Okay. So now the question is that we had so many technologies. We have been working with SQL is there for many years, right? Why we need new technology, right? Because traditional systems struggle because they cannot handle unstructured data. If you see SQL and all, they were not able to, when I say SQL, databases basically, right? MySQL and SQL Server, all those databases, those are traditional technology we had, right? Those could not handle the unstructured data. They have limited scalability and cannot process real-time data streams, right? Great. So now here comes the very important thing that there are two kinds of system, monolithic and distributed systems, right? So let me explain this with some examples. So let's say, let me open this. Okay, so what is monolithic and what is distributed system? So let's say this is a monolithic system. Monolithic system. Okay. So this is your monolithic system, right? What is monolithic system? Let's read it quickly. Single data storage, right? Let me copy this. There is some spelling mistake. Okay. So let's say this is your monolithic system, right? And it has, let's say, 128 GB RAM, right? It has, when I say system, basically there are two, three things. One is RAM, right? What is the RAM? Then you have CPU, right? There are different kind of CPU, and main thing in this will be core, number of cores. Let's say it has 16 cores, right? And it will have some storage or hard disk, right? These are the three things. Storage, let's say 1 TB or maybe 10 TB, right? Let's say you have this system, right? Now you are processing some data on this system, right? Maybe this is a SQL, MySQL or whatever, right? And it is all working fine. Now, what happens as your data is growing, right? Let's say you are a company whose data is growing, you are growing, right? There will be a point that you cannot process data with this system. And this system, when I'm saying it is, you can imagine it as a computer, right? When I say system, it is a computer, right? Now, what will happen, right? Let's say now your data is increasing day by day and you are not able to process your data, or maybe you are able to process, but it is taking a lot of time, right? Then now what you will do, you will say, okay, I will upgrade my system instead of 128 GB RAM, right? Let's say this is my upgraded system, right? And I'm saying, okay, now it will be 256 GB RAM. I will increase the RAM. I will make it 32 cores. And if required, I can increase the storage as well, right? So it is fine. Maybe few more days it will work for you, right? Because as you are growing, right, one day this system will also be not enough for you, right? Now, one more thing I want to tell you here. Let's say you were getting the performance, let's say performance you are measuring as X, right? Your performance is X with this system. Now, with this system, do you think you will get 2x performance? No, right? Because hardware have some limit. It is not that if you have doubled everything on a single system, everything will become 2 times faster. No, maybe if it is X, maybe it may be 1.5x performance you will get, not 2x, right? That is one thing. Second thing is how much you will increase, right? Tomorrow you will need 1 TB RAM, right? Hundreds of cores. I mean, you cannot have unlimited memory and everything on single system, right? So this monolithic system means that you are working on a single machine, right? Everything is happening on single machine. So what are the problems here? One problem is scalability. You cannot scale it. At some point, it will be saturated and you cannot work on a single system, right? And that is monolithic system, single system. Second problem is if this system goes down, your whole application goes down, right? Whatever data flows or ETL work you were doing, you were creating some pipelines were running. If this is a single system, right? If this system is down, everything is down. You cannot do everything, right? So those are the two main problems: scalability and single point of failure. What is the good thing about this is because this is a single system, it is easy to manage, right? Your all processes are running here. This system can manage everything, whatever jobs you are running, whatever application are running, everything can be easily managed by this system, right? Okay, so what is the solution? So the solution is that there should be a technology where I can work with multiple machines together, right? So let's say, let me take one more, right? Let's say this is your machine one, right? And then you have another machine, machine two, or maybe I can put the configuration first, then I will copy paste. So let's say this is 128, same we will take. Let me take same thing. Sorry. Okay, so let's say 128 GB of RAM, right? And then we have CPU with 16 cores. And then we have storage 10 TB, right? So this is my machine one. And similarly, I have multiple machines, right? So as my load is increasing, I'm not increasing the size of single machine. I'm adding more machines. So this is your machine two, right? Then this is your machine three, and you can have hundreds of machines, right? This is just an example, but you can have hundreds of machines, right? So how they will work together, right? This is something called as distributed computing, where you are distributing your work across multiple machines. You are not dependent on single machine as and when your load is increasing. So today with three machines, your work is happening perfectly fine, right? Now tomorrow, if there is a problem, you need more scalability, you add one more machine, right? So it becomes that simple in distributed computing, right? As and when you need more resources, you add one more machine, right? It is easily scalable. Here, let's say when you start your company, you have very less load, but still you have bought 128 GB of RAM and you are just paying for a full system, even if you are not using it, right? Or when you upgrade it at that time also. But here, nothing like that. How much ever you need, you add new machines and they will work together, right? And that is the whole point, that how they will work together. Single machine is fine, right? Whatever work is given to it, let's say you have orders data and you want category wise sales. So yeah, this is a single machine and will do the work. But how work will happen in distributed machines? So the first thing is this distributed machines uh, will be connected, right? If they are not connected, then how we will work with them, right? They should be connected so that they can talk to each other, right? Otherwise, how we will distribute work, right? So they will be connected somehow, all these machines, through a network, right? So that we have network cables, and through those network cables, they will be all connected to each other. They can talk to each other basically, right? Ultimately. Okay. So now the main problem here is that how you will distribute work, how you will manage things. In that way, monolithic systems were easy. Everything was on one machine. But here things get little complicated, right? Because let's say some work is given to you, right? Let's say there is some work. Now you have to make sure that you distribute this work to each machine, right? You don't want, so, okay, the group of machines is also known as cluster. So we call it a cluster of machines. So this is your cluster. You would have heard that you have a Spark cluster. So when I say Spark cluster, any cluster, it means there are multiple machines which are connected together through network. They can talk to each other and this becomes a cluster, and a cluster can have four machines, 100 machines, 1000 machines, right? The moment you have more than one machine, it becomes a cluster basically, right? Now, the biggest challenge here in distributed computing is distribute the work. So you are getting the work. Now you have to make sure you distribute the work so that you can work parallelly, right? Scalability means that you are able to handle large data, but at the fast pace, right? Because these machines can work parallelly. So you want some kind of parallelism to happen, right? So you will divide this work in these four machines, right? And then there should be a process where you can combine the final result into one, right? Right. So these four machines will do individual work, right? But you will not give the individual results, right? You have to give the final result to the end user, right? So you have to then combine this in the final output. So these are the two things fundamentally that in distributed computing are challenging, right? And throughout this Spark Bootcamp, we will be focusing on this thing, that how we are distributing work, how we make sure that we can do parallelism, we can achieve parallelism, right? Multiple machines can work together, and in the final, somehow we should be able to give final output, right? So this is how your distributed computing works. I hope you get the idea, right? And as we learn more things, it will become more and more clear. But main thing here is monolithic is a single system and distributed works on a cluster, multiple machines. They can work parallelly together. Great. So let's move on to this. Let's quickly read it so that it makes sense. So monolithic systems, single data storage, single processing layer, vertical scaling, right? This is also a good term. So when you are scaling a single system, let's say it was 128 GB, now you made it a bigger system, right? Let me make it little big, right? So you are vertically scaling, right? You are scaling a single system and this is known as vertical scaling. Here, when you add more machines, this is known as horizontal scaling, right? Horizontally, you are increasing the strength of your cluster, right? So this is your vertical scaling. simple consistency but limited capacity, right? So it is simple to manage but limited capacity, right? So this is your application and this is a single machine and you are doing everything here. You can read full notes later. In distributed systems, data is partitioned across multiple machines, right? Parallel data processing, horizontal scaling, right? As I said, this is known as horizontal scaling, right? Many times you will heard this vertical scaling, horizontal scaling, and in interviews also people ask what is the difference between vertical scaling and horizontal scaling. So I hope you understand it now. High availability and fault tolerance, right? This is also I didn't discuss. So here in monolithic system, right, you said that if this system goes down, everything is goes down. But here it is not the case. Let's say this machine 4 goes down. You can still work with 3 machines, right? Whatever work is there, instead of distributing in 4 machines, you distribute in 3 machines, right? Your system will not go down, right? So this is fault tolerant. Okay, high availability and fault tolerant through replication. Okay, there's another term, replication. So replication means this. Let's say you have some data, right? Let's say you have orders data, right? So in distributed system, in monolithic, you will have only one copy of this data. In distributed system, what you can do, you can keep multiple copies. So orders data, you can keep one copy here, one copy here, maybe 3 copies we want to keep, or 2 copies. Let's say if one copy is gone because of some whatever issue, or if this machine is gone, you can get it from another machine. So you can kind of replicate same data in multiple machines so that if one machine goes down, you can get the data from another machine, right? So it is fault tolerant and highly available, right? So you have this application and you have multiple machines, right? Sometimes they are also called as node. So node 1, node 2, node 3, these are basically machines which has data plus compute, right? So they will have some data that they have to process the data plus compute. When I say compute, it means RAM and CPU. So whenever I use term compute further also, so I will be using resources terms, right? In resources, one come storage and next things come compute, right? And when I say compute, compute is basically RAM plus CPU, right? RAM plus CPU. If you have worked on any cloud, you have EC2 and virtual machines. So when you create a virtual machine, it will ask which CPU you want because there are different processors, right? And how many cores you want in that? 4 cores, 8 cores, right? 4 cores means it can run 4 tasks in parallel. 8 core means 8 cores in parallel. For example, my system has 10 cores, which means 10 tasks can run in parallel in my system, right? So the higher the cores, higher number of tasks parallelly can run in a machine, right? And on top of it, we have multiple machines. So within one machine, we have multiple cores, right? And then, so for example, this machine can have 16 cores, 16 cores, 16 cores, 16 cores. So total 64 cores are there now. It means 64 tasks I can run in parallel, right? So this is how this thing work. Okay. So I'm just telling I say resources, it will be storage plus compute. And in terms of Spark, Spark is a computing engine, not a storage engine. We will discuss more. Mostly we will discuss about RAM and CPU. That what is the RAM of your system and how many cores are there in your system, right? So this is your resources. Great. If you see data is partitions plus replicated, processing happens in parallel, scaling equal to add more machines, right? Horizontal scaling, right? So in summary, one machine simpler but limited for large data scale. Distributed systems, many machines, scalable, fault tolerant, and suitable for big data. Right? I think I have mentioned it here. Okay, let me remove it. Okay, great. So now we understand that what is monolithic systems and what is distributed system. At least we have high level idea, right? Now let's understand what were the technologies in the past who were able to do it, right? And then why they didn't work and why we needed Spark, right? So the first technology, right? Or I should say first open source technology, right? Which introduced this distributed computing was Hadoop, right? Which is, I think, in 2000 or somewhere, right? Hadoop came and it showed us that how you can do distributed computing, how you can work on a cluster of machine and run your task parallelly and do your work at scale, right? Hadoop is an open source framework used to store and process large scale data across a cluster of machines, right? Now you understand this, what is cluster of machines, right? It was designed to solve the limitation of traditional systems that could not handle growing data volumes, especially when the data become too large for a single server, right? This should make sense now, right? Because if it is a single server or single machine, right, it becomes too large that one machine can handle it. And that's when we need a cluster where data can run parallelly, right? Hadoop provides distributed storage, distributed processing, and fault tolerance using commodity hardware. This is also important that we don't need any special hardware or something, right? We need commodity hardware. I mean, when I say commodity hardware, normal your laptops or my laptop, simple hardware, RAM, and CPU, we can run Hadoop on, which makes it cost effective and scalable. It became one of the foundation technology in the big data ecosystem, right? So this is, you can see the architecture of Hadoop. Now you don't need to learn Hadoop as such, right? Because Hadoop is not used now, right? But at least we should have some idea, right? Otherwise, we will not understand why actually Spark was needed. So I'll spend maybe half an hour to explain you what is Hadoop, what is MapReduce, what is SDFS, not too into detail. You don't need to know it, right? Because it is not used. But I personally feel that you should have some idea what is Hadoop, how it worked, and then we will have the answer why Spark was needed, right? So this is the architecture of Hadoop, right? You can see these are the different machines, right? As we discussed, right? That this works on cluster of machines. So you have multiple machines. In Hadoop technology, we have master machine and slave machine. Now, what is master machine? Now you have to understand one thing. When we have one system, everything is fine. This system is managing all the work, everything. But then once we have the multiple system, we need someone who can manage the, who can distribute the work. You can think about like that, right? Let's say you have a team, right? You work in a team, right? And in your team, you have a manager and 10 employees. So manager's responsibility is that he should be able to distribute the work across multiple employees, right? If there is only one employee, he will get the work, he will do it by himself. He doesn't need any manager. But when you have multiple employees in a team, you need a manager who can manage things, who can distribute the work. So that's where come master slave architecture. So these are the master. This master will distribute the work across all these slaves. These are slaves, slave 1, slave 2, slave 3, slave 4. So this cluster is of 5 machines. One is master machine, right, which will plan the work, that how work has to be done, and then it will distribute, right? And work will be done by these machines only. Whatever actual work is happening will be done by these machines only. He will just plan that what work has to be done and how it will be distributed. That is one thing. Second thing in distributed system is a resource manager or cluster manager. So let me write it. Cluster manager or resource manager. Right. So basically, what is this? So basically, now you have this cluster, right? Now in this cluster, right, there will be a lot of, let's say, lot of data pipelines or jobs or applications will be running. Let's say 10 applications are running, right? Now first app is running, let's say. So this is my app 1. This is my app 1 and it will come and start running on this. Now, when this app 1 is coming, not necessarily it will ask for all the resources. It will say, okay, I need only 2 machines to work with. It is a small work. Why to occupy all the machines? Because other people will also be running their jobs or apps on this, right? So there should be a resource manager who can manage the resources, right? So when this app 1 is asking for resources, this cluster manager or resource manager's work is to see which machines are available and how much RAM and core can be given to this app, right? So this resource manager will manage the resource, right? So basically this master machine is going to plan the work and then it will ask, okay, what resources are available, and then this will run on that. So this is how it will work basically, right? So you can see a master machine, a resource manager, which will manage the resources, right? And in Hadoop, right? So Spark is a processing system. We will discuss more, right? It is a compute system. It doesn't store any data. But Hadoop was a storage plus processing both, right? So in Hadoop, if you see, we have data nodes. So within systems, you have the data also stored, right? So this is data node, data node, data node, and this is name node. So this is basically to manage the data, there is a name node, right? And to manage all the processing, there is a master, right? So there are two things basically, right? So this is the overall architecture of Hadoop, right? Great. Now we are saying that Hadoop does both the things. It stores data also and it does the computing as well, right? Let's say you want category wise sales, right? So you should have some data on which you will find category wise sales. And then there should be a system that it will compute it, right? So it does the both the things, right? So these are the core components of Hadoop, right? SDFS. SDFS is Hadoop Distributed File System, right? So let's understand a little bit what is SDFS. So as I told you here, we have multiple systems, right? Now let's say you have some data, right? Let me take this. So let's say you have orders data you have, right? It has all the order ID, category, whatever, sales, everything you have. Now, let me call it distributed computing. Okay. So let's say you have this orders data, right? And you want to process this data, you want to run some query on this data and get some results on Hadoop cluster. Now, what you have to do first, you have to ingest this data into Hadoop. And when I say Hadoop, it is SDFS, Hadoop Distributed File System. Now, what will happen when you ingest data in Hadoop? So in each machine, you have the SDFS, basically storage is there for each machine. Now, what will happen? This, let's say this is a 1 GB data, right? Now, what Hadoop will do, it will create multiple blocks of this data, right? It will not keep this data as it is. It is not going to keep all this data together in one machine. What it will do, let's say it will create, right? Let's say 10 blocks. By default, actually, it creates blocks of 128 MB, right? So if you have, let's say, let's make it simple. So your data is, let's say, 1280 or 1200 MB, let's say, right? So how many blocks it will create? It will create 10 blocks. One block will have little less data, but a block will not have more than 128 MB of data. So you will have 10 blocks, small 128 MB blocks. So let's create those blocks. So I'll say, so let's say this is 128 MB, right? Right, and let's say this is orders one block one, or let's call it block one. Okay, 128 MB. Similarly, I will have multiple blocks created, right? Let's say there are 10 blocks. I'm not creating 10. Great. Now what it will do, some of the blocks it will put in this machine. Let's say block one is going into machine one, right? Block two is going into machine two, right? Because it has splitted the data now, right? In multiple blocks. Then we'll have block three, right? And then we'll have block four. And then one machine obviously will have more than one block, right? Let's say this is block five. Again, maybe it is sitting in machine one or anywhere. It will plan. Resource manager will plan where it has to go. But this is how it is, right? So we have 10 blocks. I've just created five here. Or maybe we can say it is a 600 MB file, right? Then it will create five blocks. It makes sense now, right? So there will be how many blocks? 128 into 4 will be 512, and the last block will be not 128 MB, it will be 88 MB, right? So this is how it will be. So if you see 128, 128, 128, it makes 512 plus 88. So we have 600 MB of data, and there will be five blocks created. And then the moment you ingest this data in Hadoop, it will be splitted into multiple blocks. So there will be, instead of one file, there will be 5 files of 128 MB, 128 MB, and they will be sitting in these machines, right? So you have distributed the data across machines. Second thing it will do is it will also replicate it. So each block it will replicate. As I said, for the fault tolerance, block 1 will not be only in machine 1, it will be in machine 2 as well. Right? By default, the replication factor is 3 in Hadoop, right? But you can change that setting. So it will be at 3 place, right? Similarly, block 2 will be at 3 machines, and you will have a bigger cluster. This is just 4 machines. You will have maybe 50 machines, but each block will be replicated in 3 machines, right? So how it will help? If one machine goes down, this block 1 you can access from some other machine. It is not that this machine is gone, then data is also gone. That should not happen, right? Otherwise, what's the point of distributed systems, right? So you want to make sure that data is replicated. So data will be replicated like this. Got it. But obviously, it will be processed for one machine. It is not that this block 1 is available here, here, here. So from everywhere, you will not process it. It is the same data. So that resource manager and master will manage it. You don't have to worry. But you should be aware that if one machine goes down, you are fine. Nothing is going to stop you in processing your data. Hadoop will know, okay, this machine goes down. I will take block 1 from machine 2 or machine 4. Right? But this is how it will be. Right? So this is your SDFS, Hadoop Distributed File System, right? Okay. So let's read it. Distributed file storage layer breaks large files into blocks and stores across multiple machines. Provides replication for fault tolerance. You should be able to understand these 3 lines now, right? SDFS is the storage layer of Hadoop. Instead of storing a file on one machine, SDFS splits the file into blocks and distributes them across a cluster. Each block is also replicated, usually 3 copies, so the system continues to work even if one machine fails. Exactly what I told you, right? This approach allows Hadoop to store massive datasets and ensure durability and high availability. Okay, great. I hope you understand this. Now, what is Yarn? Yarn is a resource manager, right? Yarn is the resource manager of Hadoop, right? It is yet another resource negotiator, manages cluster resources like CPU and memory, schedules and monitors jobs running across the cluster, enables multiple processing frameworks, MapReduce, Spark. So this Yarn is not limited to Hadoop. Yarn can be used in the Spark as well, right? As a resource manager. So there are different resource managers available in Spark. We will see later. And Yarn is one of them. So Yarn works for Hadoop and it can work for Spark as well, right? So this will manage the resources basically, that which machine has how many, uh, uh, how much, how much resources are there free so that we can use it. It will also help in scheduling the jobs. Let's say there are 10 jobs. So it will schedule, okay, this job will run first, then this job. So all of that work will be done by this. Now comes the MapReduce. This is the main thing. This is the processing engine of Hadoop, right? So we said there are 2 things. One is storage. So storage, we saw how it will store the data, right? Next thing is MapReduce, that how you will parallelly work with the data, right? And this is the core of it, right? Now, MapReduce as such, we don't have to learn, right? But the same fundamentals are used in Spark as well. Not exactly same, but you will get the intuition when you understand the MapReduce. You will understand the intuition how distributed system works, right? So now we will see how it works, right? So this is a distributed processing engine, process data in parallel using 2 phases, map and reduce, best suited for large batch processing, right? Okay, so let me go back here. I have already created one board and I'm going to explain it, how it works, right? Let me drink some water. Okay, great. So let's say you have a big orders file. It looks small, 8 records, but just for understanding, right? Let's say you have this data, orders data, and you want to process it. This is, you can imagine hundreds of TBs of data. It is not a small 8 rows, but to understand it is a small data so that at least we understand how does it work, right? So we understand that we have one file. The moment we put it into SDFS, it will be split it into multiple files. For simplicity, let's say we have two files only, right? Let's say it was 200 MB of data and it created two files, right? It will create 128 MB, 128 MB. One will be 128 MB, another will be small, right? So this data is present in SDFS. Now you will run a MapReduce program. So MapReduce program is written in Java. I'll show you how it will look like. But let me explain how it works. So first is map phase, and map phase is the one where we bring the parallelism. So imagine we have a cluster of two machines for now, right? So we have two file split and also our cluster has two machines. So what it will do when we do map, it will give me a key value pair, right? Now my requirement here is I want to get category wise total sales, right? So for each category, how much sales I have done. For example, for fashion, so first I have to do 100 into 2. So the unit price is 100, quantity is 2, so 200, right? Similarly for technology, 200, fashion 900, and so on and so forth. Then I have to aggregate and tell, okay, for fashion, how much sales is done, for technology, how much sales is done, and for furniture, how much sales is done. This is my requirement, right? So what map will do, map will process your data in parallel, right? So if you have 10 machines, in all 10 machines, your processing will happen parallelly, right? So this is your map phase and it should return a key value pair, right? In our case, key will be technology, right? Because technology wise, we want total sales. So what map will do, for each row of input, it will produce one row, right? It will, if there are four records in input, it will also give four records. For each row, it will generate a key value pair. So for example, in this case, what it will do, it will say fashion and it will multiply it 100 into 2, 200. So this is for first row fashion and this is the sales. For second row technology sales. So this is how it will give me in the output key value pair. Key is technology and value is my sales, which comes by multiplying prices into quantity. And these two machines will run parallelly. One block or how many number of blocks this machine has, it will process it and this will process it. So basically, we will be able to do some work parallelly, right? Imagine there are 100 machines, then they will be able to do this 100 times faster, right? Because they are all running in parallel. So this is the first phase, map phase. Let me read it, right? So uh, MapReduce is a Hadoop's original computation framework. It works by splitting a job into smaller tasks that run in parallel across machines. The map phase processes the input and extracts key value pair. That's what we say, right? So it will process the input data and extract the key value pair, right? While the reduce phase aggregates or summarizes results, right? So if you see, now what is the next thing we have to do? This is fine, row wise we got it, right? But this data is on different machines, right? You understand that this is one machine, this is one machine. Now don't you think I have to bring this data to one place, right? At least each key I need to bring it to one place. So fashion 200 is there. I have to make sure fashion 200, fashion 900, and from here also fashion 400 is on one machine. Then only we can aggregate. Then what will happen? We will have a shuffle and sort phase, right? So we will shuffle the data. When I say shuffle data means I'm moving data from one system to another system. That is shuffle, right? I'm moving data from one system to another system. And also I need to sort the data so that each category is together, right? So this is how reducer will receive the input. So it will receive fashion and all the values of fashion. So we have 200, 900 and 400. So you see 200, 900 and 400. So this is my reducer. And then technology 200, 200, 500. This shuffle and sort is costly because we are moving data from one system to another system. Until and unless everything was happening in this system, everything was fine. But the moment I say I have to shuffle data, there are other things also come into picture that I'll just explain. But let's complete this, right? So we will have this kind of data and then it will say, okay, sum this up. So it will say fashion and sum this up. Technology, sum this up. Clothes, sum this up. Furniture, sum this up. Right? And this is how I will generate the output. Now it is not necessarily that there will be only one reducer. There can be two reducer, right? So I can have one more reducer here, two machines basically, reducer, right? And maybe all the fashion data is going here, fashion and technology, right? And clothes and furniture is going there. That is also fine. But same key data will go to same machine. That it will make sure, right? It is not. It should not happen that fashion is going, two rows of fashions are going here and one is going there. No, that will be wrong. Then we will not be able to get the right data for fashion, right? So let's say there are 100 machines, 100 mappers, and there are two reducer. Imagine that, right? So sort and shuffle will happen, and some data will go here, but same key data will go to same machine. If fashion has 100 rows, all the 100 rows data will go to one machine. It will not be in two machines, right? So this is how reducer will get the input, and then it will generate the final output. Right? If you have two reducer, you will see there are two files in the output, right? If there is one reducer, there will be one file in the output, right? So this is how this map reduce works. Now, what happens here is very important. So when I say shuffling is happening, data is moving from one system to another system, right? So everything till here was happening in memory itself, right? So whatever processing happens, maybe it is Hadoop or Spark or any technology, any kind of transformations or processing happens, it always happens in RAM, right? But when you have to shuffle it, it has to be written to the disk first. So this is a system which will generate this data in memory, but before shuffling, it will write it to a disk, right? So imagine there is a disk here. So this is a disk. When I say disk, it is hard disk basically, right? So I have a disk here and I have a disk here, right? So to move data from one system to another system, this data has to be written in disk. Similarly, this data has to be written in disk. Once it is in disk, then only it can transfer from here to another system. Right? In-memory data directly cannot be transferred, right? So this is the limitation. Even in Spark, we will see that some place data has to be written in disk, right? But ultimately, if you have to move data from one system to another system, you have to understand that it has to be written in disk, right? And this is a costly operation, right? Because writing into disk and then again reading it and through network taking it to another computer is a costly operation, right? So this is how this will work. Great. So this we understand that how map reduce works, right, at high level, right? So the map phase processes the input and extracts key value pair, while the reduce phase aggregates or summarizes results. Although map reduce is slower compared to newer engines like Spark, it was the first framework to enable large-scale distributed data processing, right? So you have Hadoop, right, and you have SDFS where data is stored. Then you have Yarn, which is a resource manager, and you have MapReduce, which does the parallel processing, right? Now let's see what are the challenges with Hadoop, right? Why this technology didn't work for long and we had to move to Spark. So the first thing is slow processing. Hadoop uses disk-based processing, making jobs much slower than modern in-memory engines like Spark, right? So as I said, let's say you have multiple transformations that you have to do, right? So let me create another block, right? So let me take this. So let's say you have some map reduced job. You created a map reduced job. Now, many times you have to create multiple transformations in your system, right? Let's say so you are chaining the map reduced job. You write one map reduced job, then another map reduced job, right? And then there is another map reduced job, let's say, right? So there are multiple transformations you are doing. So the result of this, you are taking and again doing some transformations. Then again, result of this, you are taking and doing the transformation. Every time you do this, every time you take this and run another MapReduce program, in between it will be written to disk. And that was the major bottleneck with MapReduce, right? That every time it has to write data to a disk. And this operation is very costly, as I told you, right? Writing data from memory to disk and again then reading in the next phase, then writing, then reading. Right? This was taking a lot of time, right? And this was one of the bottleneck of MapReduce, right? So if you see here, it is saying Hadoop used disk-based processing, making jobs much slower than modern in-memory engines like Spark. It's designed for batch processing and struggles with real-time or streaming use case, right? So with Spark, you can have streaming data, real-time data, but Hadoop was mainly for batch processing only. Difficult to maintain, running and managing Hadoop cluster requires significant operational effort and tuning. Complex ecosystem, the Hadoop stack is large and can be difficult to integrate, manage and learn. So when I say Hadoop, there were a lot of technology in that ecosystem. For example, we had Pig, right? The system is this basically SDFS and MapReduce, but there were different technologies like Pig was there in the Hadoop ecosystem where you can do scripting, right? Then Hive was there where you can write SQL on the SDFS data. Then OZ was there. I think it was to schedule jobs and all, right? Then we had HBase, which was the NoSQL database for Hadoop. Then we had Scoop to connect with external systems, right? So there were a lot of technologies that you have to learn. If you are working on Hadoop, you have to learn a lot of things, right? And it is very difficult to integrate and manage, right? So this is one of the main bottleneck apart from that MapReduce problem, right? Hard to develop. Writing MapReduce code requires low-level programming, making development slower and less flexible for data engineers, right? Let me show you some. So this is MapReduce. Whatever I explained you, you can go through it. But let me show you some C. So this is my MapReduce program, right? If you see, it is written in Java here, right? And then it has multiple phases. So you will have to write some for map and as well as reduce, right? I think map phase, I think my code is, I removed it, but I will add it. So you have to write two code. One is for map in Java and another is for reduce. So this is the reduce phase. And you see, this doesn't look so intuitive, right? So when I learned Java, I learned in back in 2014, right? And that time people used to write MapReduce program in this Java, right? And I never learned Java, to be honest, right? I was from non-tech background and I was like, what is this? Who will write this kind of program, right? This is a small program, but imagine you have to write big programs, MapReduce programs in Hadoop. It was not easy, right? So learning MapReduce and Java was also a difficult task, right? So this is another reason why we have to move to some other technology, right? So performance issues, lots of disk IOs, hard to write the code. MapReduce supports only batch processing. Lot of things to learn. Pig, Hive, HBase, Scoop, etc. No interactive mode, right? So there was no interactive mode. So for example, if you have worked on notebook, right? You write something, you get the output, right? On SQL, you write a SQL, you get the output, right? But in Hadoop, it was not like that. It was like you package your code to create a bundle, right? You have to create a jar code, something, right? Hadoop jar. And then you send it to the Hadoop cluster and it will generate some file set output, right? So you cannot, you didn't have the interactive mode that you send the command, you run some command and you get the output. That was not supported, right? So that is also not big developer friendly, right? Have to bundle full code and run it on the cluster and output files will be generated, right? So there was no interactive mode that immediately you see the results, right? So these were some of the challenges with MapReduce, right? Great. I think we understand now that how distributed computing worked with Hadoop, what is SDFS, what is MapReduce, right? Now, before we start talking about Spark, I'll take a 5 or 10 minutes of break, right? If you have any questions so far, you can ask. Otherwise, you can just take a 5 minutes break and we will start at 12:15 India time. It is 12:05 in India. At 12:15 we will start. 10 minutes break we will take. If you have any questions, meanwhile, you can ask.
Yeah, Ankit.
Hi, Robin.
Yeah, Ankit. Actually, I have asked a question at the top itself. Like there are a lot of things. First thing I want to understand, like what's the major difference between the yard and the name node actually? because they both seems to be same, right? So yarn and name node, how they are different from each other?
No. Yeah. So, okay, let me go back to the Hadoop architecture. Right. So as I said, Yarn is a resource manager which will manage the resources, right?
Mhm.
It will,
Okay.
so when you submit a job, right, master will ask, okay, that I need to run this job. Can you tell me on which machines I can run? It will check which machines are available, and master will send the code to those machines, right? Name node is keeping track of all the data, right? So in master, right, we will have a name node. It will keep track that for which table, which data is where, right? So for example, you have a orders file. So it will have data, that orders file, in which machines data is there and which blocks are available in which machines, right? So let's say you have 100 machines. It doesn't mean that in all 100 machines you will have orders data. Maybe you have only 256 MB of data, so it will be in two machines. So name node will all manage it, right? Let's say one machine goes down, then it is name node responsibility to tell, okay, you can process data from other machine, right? So this is what name node is. It is not
So,
managing resources. Resource manager is managing everything. It is managing the job, which resources are needed. Then it will schedule the jobs as well. All resource thing it will do. It is just managing the data in SDFS. That's it.
so master name node maintains it's like a index that where what is kept, right?
Right.
Right.
Data.
And what
Right.
and yep. And the master node is the gateway computer through which that work is coming, or it's like the
No, it will
how does it?
also, master node will also distribute the work, right? So if you have, let's say, some job, right? Then it will make the plan, okay, what work has to be done, and then it will distribute the work, master.
Okay. So there are two separate things. Name node and the master node, they both are separate,
Now, so
right?
node will be sitting in the master system only. It will not be
Okay.
sitting separately.
Okay. And
Yeah.
resource manager is a separate system altogether.
Yes. Yes.
Okay. Got it. Thank you.
The similar kind of architecture you will see for Spark as well, but it is little different. But overall idea is same. You will have some
Mhm.
slave machine, some master machine, resource manager, kind of same, but it will be different. So we'll discuss.
Okay. Okay.
Yeah.
Yeah.
Next.
Hi, Ankit.
Yeah. So
Am I audible?
yes. Go ahead.
So my question is on it's a little off topic, not related to the topic. Mostly, I
Then you
mean,
can
course related.
we can take at the end if it is not topics related
Okay, all right, cool.
after the session, right? Thank you.
Yeah, hi again, Amit this
Yeah.
side.
Yeah.
So for Hadoop or any distributed system, just like we have different machines which is being managed by master,
Yeah.
and master maybe have two helpers, we can say resource manager and name node. So we can have multiple masters also, right?
Why you need multiple master? Master will be one.
So because in Spark we can have multiple drivers, right? Driver is also a master, right? Kind of.
Uh, yeah, you can say so. We have different kinds of cluster in Spark. We have a standalone cluster.
Yeah.
We have Kubernetes. We have this Yarn. They are little different how it is managed. But mostly you will have one driver.
Okay. Because generally we in Spark, if it's not a standalone cluster,
No, you
so
have multiple executors, but driver will be one.
but what in case if we have multiple drivers, then
Okay, we'll discuss when we reach
okay,
Spark. For now, let's discuss about Hadoop.
okay,
Yeah.
got it. Thanks.
Okay. Anyone else?
Hello. Hi, Ankit.
Yeah,
Uh,
Kaushik.
can you just like repeat the disk storage for like I didn't understand like why we have to write it to the disk again in between
Yeah.
each.
So you have some data in RAM, right?
Mhm.
So from RAM, you cannot take data directly to another system. If you have data has to go through network to another system, it has to be written in disk.
Mhm. Mhm.
Directly, data cannot be moved from memory to through network to another system.
Okay.
That is
Okay.
hardware limitation.
Mhm. Mhm.
Sorry.
Okay. Thank you.
Hi, Ankit.
Yeah.
Uh, so I wanted to ask, like, what would be considered like big data for us for a business to use Spark? Like
Simple, right?
big.
If you are not able to do in a single system, right, you are hitting the bottleneck, or in a single system, your pipelines are taking a long time, right? So it is the time that you have to move to distributed system. As simple as that.
So anything like that we say like GB or TB a scale on that
We cannot say
generally.
that, right? You might have
Okay.
a lot of data, but you are doing very less processing, right? Maybe you can manage, or you may have not much data, but you have to do a lot of processing. So it all boils down to if you are able to do it in single machine, do it. If you are hitting a bottleneck, move to distributed system. This is how it is.
Okay.
There is no
Okay.
definition that on 100 GB you should move. Nothing like that.
Okay. So you're saying like if competition is very high, you might consider if it is showing bottlenecks.
Right, right.
Okay. Thank
Okay. Sorry.
Hello, Ankit.
Yeah.
Yeah,
Yeah, Arvind.
Happy New Year, first of all. Yeah, actually, I have a question. You say the master have some configuration and the slave also have this configuration. So master have the more configuration like to slave or the same configuration?
What do you think? What your intuition says? Master should have more
Actually,
or
maybe master has some more because they are getting a lot of data, right?
no? So master is not processing any data. You understand? Master is not, it is just seeing what is the work and then it will distribute the work. But master doesn't store any data and it doesn't do any data computing. It just makes the plan, right? And for that, you don't need much memory. Ultimately, resources will go in processing the data, right? Imagine this is processing 100 TB data, 100 TB, 100 TB data. You are doing some transformation. So this needs good amount of memory and CPU. This is just doing a planning, isn't it?
So a slave have the more
Yeah.
configuration, right?
So they have to do the heavy lifting. It is just doing the planning. It is not handling any data. It is just seeing what is the job. It will create the plan and distribute the work. That's it.
And resource manager, uh,
Resource
it also
manager is
has the same.
managing the resources basically. How many systems are there? How many resources are available? So if master wants to send some work, it will ask resource manager that in which nodes I can send my work, to which slaves or which employee I can send my work. So it will tell.
So after the processing, this send back to master or resource manager.
So once the processing is done, it will write the output to the files. It will not send it to anyone. As I said, in Hadoop, it will always write data. It will always generate the output files, right? So each slave will generate an output file and it will be written somewhere and you can see the results. It will not send it back anywhere. In Hadoop, I'm not talking about Spark. Okay. It will just send the signal that work is done. That's it. Great. Anyone else? Last doubt I will take, then we can take at the end.
Hi Ankit. Hello.
Yeah, go ahead.
Ankit, regarding this distributed computing,
Mm-hmm.
so let's say if I have a, cluster of three nodes,
Mm-hmm.
data nodes, let's say,
Mm-hmm.
okay, and I triggered one job which is processing, let's say, 1 TB of data size.
Mm-hmm.
So at that time, these blocks will be created and the data will be basically in the RAM. It will be available, right? And then let's say the machines, each machine is 128 gigabyte, and
Mm-hmm.
60% of the consumption is done across each machine while processing this data. And
Mm-hmm.
meanwhile, I trigger another job along with this. So
Mm-hmm.
how the resource manager will be basically processing it fast when there are two high jobs are running or heavy jobs are running, or maybe let's say 3 jobs or 4 jobs in parallel.
So there are two different things. One is, right, so when you submit a job, right,
Mhm.
you may have dynamic allocation, right, where you will say, okay, whatever resources are there, you process data with that, right?
Yeah.
Another is you ask fixed resource that I need these resources minimum, right? In that case, if those resources are not there, you will have to wait. That job has to wait previous job to finish.
Okay, okay. So basically, if there are multiple jobs running in parallel, even then the distributing will wait until
Right.
resources are
But if
available.
you don't have resources, you cannot do much, right?
Yeah, yeah.
There is no magically.
Right. And how do we basically know that? Because we don't know in future how many jobs we have to run in parallel, or maybe how many analysts or engineers are so how we
So
know?
generally, wherever you will schedule the jobs, right?
Yeah.
You see that how much is the wait time and then how much processing time. So you will have to see, okay, my job had to wait 2 minutes. You will add more cluster, right? So that this thing that doesn't happen next time, right? So it's like ongoing problem to figure out. If you need more resource, you will have to add more cluster. If it is all going fine, you just keep the cluster.
Okay, okay. And I actually missed some part of MapReduce.
You
Like
can watch the recording after the session.
so in just to understand, like in MapReduce phase also, the data will be temporarily stored on the disk, right? But in Spark, it will not happen. Everything will be processed.
Not everything, but most of the things will be processed in RAM.
Okay, okay.
There will be few cases where it will be written to disk. We will under. But in MapReduce, if you have multiple transformation or MapReduce jobs, right, every time it will run into disk. But in Spark, we can chain together and run all of that together in RAM, right? So we will see that.
Okay, okay. Thank you. Yeah.
Yeah. Another thing, okay, let's resume the session now. Another thing in MapReduce is, right? So you are writing a map program, right? Let me go to MapReduce. So you are writing a map program, right? And also you have to write a reduce program. So as a programmer, right, you have to think like that this is a distributed system, right? Your program also dependent on that it is a distributed system. So you have to write a map program accordingly. Okay, this will go to maps and this will run all in parallel. Then reduce program will be like this, right? But in Spark, it is not like this. You don't have to think that it is a distributed system. You just have to write. For example, you can write, I'm giving a simple example, select stuff from orders where uh, category equal to something, let's say technology, right? So here you are not thinking about distributed system. You are just writing what you need. That's it. Spark will take care that how it will run in parallel, what it will do, how it will partition data, everything, right? But in map reduce program, as a developer also, you have to think like that. That you have a map phase, reduce phase. This is my program for map, this is my program for reduce. But in Spark, that goes away. You don't have to worry about how Spark will do. You just have to write your program like normal, right? And it will just do it, right? And I want to clarify one more time that SDFS is a permanent storage. It is not temporary. I think some of you are thinking SDFS is a temporary storage. No, SDFS is a permanent storage. So what you are doing basically, the moment you have the orders file, right? And then you will ingest into SDFS, right? Or maybe I can explain it here. Mm, I think another one I created. Yeah. So the moment you ingest the data, this is permanent in machine 1, machine 2, machine 3, machine 4, right? So when you run the map the job, right? Machine will pick data from this system. Now machine 1 will not go to machine 2, right? Whatever data machine 1 has for orders, right? Block 1, it will process that. Whatever data machine 2 has for orders, it will process that, right? So this is known as data log. Wherever your data is in whatever, and this data will remain as it is unless you delete it. It is not temporary storage, right? MapReduce processing is temporary. So whenever you run a job, it and process it, and that's it. All free now. But this SDFS store is persistent. It will be there always. Right? I hope it makes sense. Great. Now let's what Spark is, right? So let me go here. So let's understand. So what we have currently, right? So we have data ingested or data. So typically in data engineering, we have ETL pipeline, right? You have extract, transform, load. Right? So in case of Hadoop, what you are doing, you are first ingesting data to SDFS. Right? Once your data is right, you will do a processing. Right? Your MapReduce will run, and then it will write file to output somewhere. This is how it is. Now, what's Spark is not a replacement of Hadoop, right? Spark is a replacement of MapReduce, right? Because Spark is not a data storage system. In Hadoop, you have SDFS where you can store data, but Spark doesn't take care of your storage and all. What you have to do, you have some data source. It can be SDFS, it can be S3, it can be MySQL, it can be your Azure storage, anything. Right? To get that data and process it in Spark and write it back somewhere. Right? This Hadoop is tied to SDFS, that you have to set up SDFS and then MapReduce jobs will run on that SDFS system. But in Spark, nothing like that. Right? Spark is an in-memory data processing system. I'll just show you the definition. So it is kind of plug and play system, right? You have some data, you plug it in between, do your processing in memory, right? And then write it back. That's how it works, Spark, right? So when someone says the Spark replaced Hadoop, it is wrong, right? Spark replaced MapReduce, right? The bottleneck was MapReduce, where data has to be written multiple times to disk. There was a lot of IO involved, which was slowing down the jobs. So instead of MapReduce, we are using Spark, right? And it is said that the Spark can run 100 times faster than Hadoop. MapReduce, sorry. Right? So this is a plug and play kind of thing. This you have to understand, right? Great. So now I'm saying that this is a plug and play system. It can read data from SDFS as well. So if you have set up in your machines and you can run Spark on top of that, that will also work, right? But you can also have a data lake, right? So data lake is like S3 or Azure storage or Google storage. If you're not aware of data lake, let me give you little bit idea what is data lake, right? So let's say you have different systems. So for example, you have, let's say your bank app, right? This is a transaction system, or let's say Namaste SQL website, or let's say Zomato. These are all transaction system where actual transactions are happening, right? Now, this is fine. This is your transactional system. Now you have another analytics system here, right? Let me create here. It will be better to explain. Let me create a new board. Okay, so okay. I'll just give you an idea. Maybe some of you are not aware of what is data lake. So it will not make sense. So let's say you have Zomato app. This is your transactional system where all the end users are doing transaction, right? Namaste SQL is also like that, right? Or let's say your bank app. Let's say your ICICI Bank app, iMobile. These are all user-facing system, and ultimate data is getting generated from here, or maybe LinkedIn or YouTube, right? Data is getting generated from these front-end systems ultimately, if you think about it, right? All the processing and all we are doing somewhere in Spark, Hadoop, whatever. Ultimately, data is getting generated here, right? Now let's say you have Spark here and you want to process your data, right? You have an analytics team and you want to process some data. Now one way is you okay, before I go there, these all systems will be storing data in some database, right? So this Zomato app, whatever transactions are happening, it will be storing in a database system, right? Generally, there are RDMS system, RDBMS, like MySQL, right? For example, MySQL, Postgres, or whatever. Or it can be NoSQL databases like MongoDB, DynamoDB, right? So it depends on architecture and all. But basically, there will be a transactional system, NoSQL it can be, right? Where data is getting stored for Zomato app, or for example, Namaste SQL, we store data in MySQL, right? RDBMS system. Similarly, ICICI will also be storing in somewhere. So your data is sitting here, and these are very busy systems. You have to imagine, right? Because every time someone is ordering something, you have to write some data here. Then whatever data is there, you have to read it back to show what is the order summary and lot of things, user profile, right? So these systems are traditional. These transactional systems are very busy, right? And they are live production systems, right? You cannot afford that these systems will go down. If this goes down, the Zomato app is gone. You cannot deliver, you cannot place orders, right? So now, like your data is sitting here, all of the data. Now let's say this is your Spark, right? You want to process this data, you want to do some analytics. One way is you directly connect this, right? And fetch the data, right? Okay, no problem. You can connect to your MySQL and fetch the data in Spark and process it. But do you think there will be only one job? If you have data analytics you are doing in your company, there will be multiple jobs, right? So there will be, let's say, Spark application one, right? It is doing some work, right? Then again, another app is there. It has to get the data, right? Then app three is there. It has to get the data, right? And it becomes very multiple jobs will be connected with this RDBMS system. Now, the problem here is if you are extracting data and querying data from RDBMS system multiple times, you are adding load to this transactional system, right? Same data, let's say orders table, you want to get multiple times for app 1, for app 2, for app 3. You are again and again touching the transactional system, querying it, and unnecessarily you are increasing load on it, right? And you don't want to do it. That is not a good thing. What you will do, instead of directly connecting your Spark app to this system, you will create a data lake, something called as data lake, right? So a data lake will be here, sitting somewhere in between. And data lake is nothing but the hard disk in cloud. You have a S3 and all, right? These are very cheap because this is just a storage system. So what you will do, let's say this is AWS S3, right? You will just get this data from your system, right? You read it once and dump it into S3. So you read it and dump it into S3, right? Once. So every day, maybe every day at the end of the day, whatever new data is generated, you will just keep adding it into your S3, right? So all your data is in S3 now. Now, any analytics you want to do in place of going to RDMS system and making it busy unnecessarily, you can just go here and get it multiple times. Right? This is just a storage. So you can, this Spark app 1 can also read data from here, app 2 also read from here, app 3 can also read here. So these system will not be impacted by your analytics work, right? So this is known as data lake. So you typically work with data lakes. You read data from data lake in your Spark application, process it and write it back to, again, you can write it to data lake or delta lake. We'll discuss that. But this is what this data lake is basically, right? Something between your analytics and transactional system, something is sitting so that you don't put much load on your transactional systems. Okay, so this is your data lake. I hope it makes sense. Okay, so now coming back to here, so we have these apps, and then so basically your data is in data lake, right? You will read data in Spark and write it back. Right? This is how it will happen. Right? So your Spark is a replacement of MapReduce, not Hadoop. Okay. Now you will say that you are saying that you can read data from SDFS as well as from data lake, right? In Spark. This is what we are saying, that Spark supports both. You can ingest data in SDFS or you can read from data lake. What should I choose? That should be your next question, very obvious question, right? So let me tell you that most of the organization, right, data lake, right, choose data lake, right? Instead of SDFS, we choose data lake, right? And that is what we are going to discuss now, that the difference between SDFS and cloud data storage. Data lake or cloud data storage, same thing, right? So let's read it quickly. SDFS is the storage layer of Hadoop. It is designed to store large data set across multiple machines in a distribution and fault tolerant way. Instead of storing data in a one server, SDFS splits it, and all of this we know, right? It has a name node. It will have the metadata that for each, let's say, orders file, where all data files are there, right? So it will have all the metadata of data distributed in SDFS, right? So name node stores metadata about files, directories, and block locations, does not store the actual file, right? So name node is just the metadata of where my data is, acts as the central controller of the file system. Data nodes stores the actual data. This data nodes are sitting in my machines only. It is not different machines, right? So I have this Hadoop cluster, right? So this data nodes are sitting here only. It is not different machines, as I said, right? They stores the actual data, perform block read write operation, send heartback and block reports to name node. So they keep sending heartbeat so that it knows that this machine is alive, right? Let's say heartbeat is not there, the name node will know, okay, this machine has gone down, so we have to process data from somewhere else, right? And then replication also we know. And this we discussed, how it will be stored, a large file will be broken, and we have discussed all these details. I'm not going to again explain this. It will be replicated. We want to discuss challenges with SDFS, right? So now there is one big problem with SDFS, if you can think of it, right? Now you have these systems, which is fine, right? Now let's say you don't want to process any data as such. You want to get some data for some other purpose, right? Let's say you have some data in here, right? You are not doing any processing. You just need that data for whatever purpose, right? Don't you think you have to bring this server up, right? Bring server up means you are paying for it. When you don't need this machine, you will just shut it down, right? Because all of these machines are bought in cloud system, EC2 machines and all, right? So the moment it is up, you have to pay for it, right? So your compute and your storage are tightly coupled here, right? So even if you need a data from here, SDFS, you have to bring the machine up and then do the processing, right? And let's say you have multiple platforms. Let's say Spark is there, which is fine, right? Let's say you have you want to read your data in Snowflake as well, or you want to read data in your Google BigQuery, right? Then again there is a bottleneck, right? You have to connect to SDFS, right, and bring that data in those systems, right? So that is one problem, that compute and storage are tightly coupled, right? So once you move to the cloud storage, right, your cloud storage is a separate object storage system. So now these machines are only for processing, right? If you are not using SDFS, right? So you have your cloud system here, let's say. So this is your data lake, right? Right? All your data is sitting here, not sitting in SDFS, right? You just bring the data and in memory you will process it and give it back, right? And let's say tomorrow you want to do something on Snowflake, you can connect to Snowflake as well, right? You don't need to bring your servers up of your cluster, right? They are sleeping, let them sleep. You just you open your Snowflake and connect to data lake, get all the data. You need on BigQuery, you connect your BigQuery to data lake, get the data, right? So there is no vendor lock-in as such, right? Same data can be processed in the by different vendors or different systems, right? This is one of the advantage of data lake. So everyone, mostly you will see all of the data is in data lake. There can be some old companies where old processes are running. You may see SDFS, but mostly you will see the data lake, right? Okay, so let's read it. While SDFS played an important role early in the big data world, it comes with several limitations. Scaling requires physical hardware, right? To store more data, companies must buy and manage more servers, right? If you want to store more data, you will have to buy more machines, even if you don't need more processing, but still you want more machines to store data, right? Not persistent. Storage is tightly coupled with compute. If cluster goes down, then you cannot access the data, right? So if the cluster goes down, there is some problem, data is also gone. But in case of data lake, right, it is separate. Even if the cluster goes down, you can still interact with your data, right? Single point of failure, name node. If the name node goes down, the entire system becomes inaccessible, right? Because name node has the metadata, right? So if the name node is gone, you cannot access anything, right? And then we have high operational overload, needs dedicated teams to manage cluster failures, application balancing, lot of things. Not cost effective at large scale, replication 3 times means storage cost triples, right? Not ideal for real time on interactive workloads, and on premises logged, right? So you have servers, right, which you have to buy servers, and then you have to put your data there, right? So all of that problems are there. So now shift toward cloud data storage. Modern cloud storage systems like Amazon S3, Azure, Google Cloud Storage address many of these limitations of SDFS. It is elastic storage, right? Scale storage instantly without buying hardware, right? So, for example, if you want to store more data, right, your cluster is as it is. You don't have to touch it. You can just put more data in your data lake, right? You will just pay for whatever you are putting in your data lake, whatever 100 GB, 200 GB is there. So compute and your storage are decoupled, right? You can manage compute at whatever computation power you need, and whatever data you need to store, you can store in your data lake, right? So these are decoupled basically. You can scale your storage, and if you don't want to scale your compute, it is absolutely fine. And vice versa, you want to scale your compute and not want to scale your storage, it is absolutely fine, right? No infrastructure maintenance, no need of managed disk replication, nothing. You just put it into S3, and it is AWS responsibility to create the replication so that high availability is there. So internally, AWS also will create replication in different data centers. It will replicate the data. But for you, it is like you are dumping your data in data lake. So you don't have to manage anything. No infrastructure maintenance. Lower cost, pay only for storage used. No upfront capital expense, right? In this case, you have to have upfront expenses that these machines I will buy and I will pay for it. Here, as and when your data is growing, you are paying for that data. That's it. High durability and availability. Cloud providers handle replication across regions and zones. So that is also not an issue. Separation of storage and compute, right? So your storage is different and compute is different. Compute engines, Spark, Snowflake, Databricks, BigQuery can scale independently, right? Supports multiple processing engines, right? So you can have SQL engines, Spark, everything. So basically you are decoupling, right? So organizations are adopting cloud platform because they offer scalability, flexibility, lower operational cost, and faster innovation. Unlike on-premises Hadoop environment, cloud platforms provide serverless or managed services that reduce operational complexity and adapt easily to growing data workloads, right? So I hope you got the idea that what are the advantages of this cloud storage and what are the challenges with SDFS, right? And now wherever you are working, 99% chances are you have all the data in one of the cloud providers, either AWS, Azure, or GCP, right? So this is your data lake versus SDFS. Great. I hope it makes sense. Now what I will do, I'll give you a quick introduction of Spark, and then I will tell you how to install Spark in your system, right? And then we will end the session. Great. So as I said, Apache Spark is an open source analytics engine used for big data workloads. It can handle both batches as well as real-time analytics and data processing workloads. Right? So it is an analytics engine. It is not a storage or anything. It is just for processing the data. All the transformations, everything that you will do, that Spark will do, but it will not store your data as such. Apache Spark started in 2009 as a research project at University of California. Researchers were looking for a way to speed up processing jobs in Hadoop systems. It is based on Hadoop MapReduce and it extends the MapReduce model to efficiently use it for more types of computation, which includes interactive queries and streaming processing. Right? So this is how it came, right? Hadoop was there, but then there were a lot of bottlenecks, jobs were slow, so then came the Spark. Also, Spark provides native binding for Java, Scala, Python, R. In addition, it includes several libraries to support and build applications for machine learning, right? So in Hadoop, right, you have to write MapReduce programs in Java, right? But it provides more options, right? You can write SQL or you can write Python and different things, right? So that is another thing, right? So you can read it. I'm not going it, but I'm just reading this line. In summary, Spark is a multi-language, in-memory, distributed compute engine. It's a plug-and-play system, right? So it is a multi-language, right? Someone was asking, I think, that what is the difference between Spark SQL, and PySpark. Right? So Spark is a processing engine, ultimately the engine which will do the work, right? And these are the different way to talk to the Spark. You can write SQL or you can write the Python API of Spark, right? So if I have to take an analogy, let's say you have a cook, right? Cook is your Spark, right? He will ultimately prepare the food for you. Now you can tell what to make or how to make, either in English or Hindi, or you can write it. So there are different ways to communicate to your cook, right? So these are two different ways to talk to Spark. There are more ways, but we mainly will focus on these two, Spark SQL and PySpark. It is a simple analogy. I think it should make sense. Okay, great. Spark is just a replacement of MapReduce, and Spark abstracts away the notion that you are writing code to run cluster. You just run a SQL code or PySpark code and it just runs on cluster. As I said, right? You don't have to think about it as a cluster. In MapReduce, you have to write, okay, this is a map job, this is a reduce job, but here you don't care about it. Spark will take care of it. You just have to run a query that I need this, and it will give you. How it will be done, that we will learn, but Spark will take care of it, right? So it is a in-memory computation. We will spend a lot of time that how it is in memory and all. But for now, you understand that it does everything in memory. Where MapReduce had to write multiple times on the disk, it doesn't do that. It does most of the things in memory itself, right? Keeps intermediate data in memory 100x faster than MapReduce. Unified engine, one platform for batch streaming ML graph, right? So you can do machine learning, you can do batch processing, you can do streaming, you can do graph things. So everything you can do in the same engine. Ease of use, right? They have APIs in Python, Scala, Java, R, and you can also do Spark SQL, right? So ease of use is there. Now there comes one concept of RDD, right? Resilient distributed data set, core abstraction of fault tolerance parallel computation, right? So basically, whenever you read data in Spark, it will be stored in RDD, right? So in the next session tomorrow, we'll spend good amount of time on these two topics. What is RDD and what is lazy evaluation, right? So I'll keep it for now. It's okay if you don't understand, but basically data will be stored in the form of RDD in your Spark, right? Same thing, I think. Let me quickly take over, explain you the architecture. It is very similar to how we saw for Hadoop, but little different, right? Now, this architecture I'm giving you at very high level, right? At this point, if I go deep, you will not be able to understand. So we will spend some time, maybe a few more lectures. We will write some code. We'll see Spark UI, and then later we will go deep into the architecture. But for now, because we have to install Spark, we should at least know that how it is, right? So this is your Apache Spark architecture, right? You have a driver here. right? It is kind of master node, right? Then you have a cluster manager, and then it is executor or worker node, right? So terminology is different. There we call slave. Here we call worker node or executor. You will know the difference between worker node and executor later, but it is a worker node for now, right? So you have a driver and worker node. Okay, so this is kind of worker nodes will do the actual work. Like in Hadoop, we have slaves. Here it is executor or worker node which will do the ultimate work. The cluster manager is similar thing, that it is a resource manager. It will manage the resources, right? And then you have the driver, right? Driver is the person or master node, you can say, who will plan things. So when you submit a job, right? So it will plan that, okay, what all needs to be done, right? Then it will go to cluster manager. It will ask for resources. Okay, from where I get the resources? Cluster manager will go back, tell, okay, you go to these worker nodes and run your job. So the jobs will run. And once the job will run, depending on what you want to do, it may give back result to driver, or it may just write the result somewhere else, right? So it is not necessarily that executor will always give back result to driver. In some case it will give, in some case it will not. That we will see, right? But basically these executors or worker nodes are the one who will be doing the work, right? This will be distributing the work, and this will tell, okay, that what are the resources available, and it will give it to the driver, and driver will send the work, right? So this is your at very high level Apache Spark architecture, right? Now another thing is, right, that how you make entry to the cluster. So this is your cluster, right? If I'm just running a code, let's say I'm saying a equal to some list on my Python program, right? So this is not going to cluster, right? If you want to enter into cluster and you want to run your code into your cluster, there is something called as Spark session, right? Every Spark application starts with a Spark session. You can think of this as the main gate or entry point of your cluster, right? So this is your entry point to the cluster, right? Now, if you have learned C++ or Java, you will see there will be a main program you will always write, and your program will start with main. Similarly, you can think of it, if you want to work with Spark, your Spark session will be your entry to the cluster, right? Once you create the Spark session, through this session, you can then work with driver nodes, and you can send the data to executor, talk to cluster manager, and all of these things you can do. Okay, great. So let's read it quickly, right? Every Spark application is start with Spark session. You can think of this as the main gate or entry point to the cluster. Whenever we read a file, run a transformation like filter group by or write the result to a file, it's all done through the Spark session, right? So this is how you create the Spark session, simple. From PySpark.sql, import Spark session, then Spark session.builder. Then you can give a name of your app, then get or create. So it will create a Spark session, right? Then driver program controls everything. When we run our Spark application, it gets picked up by something called driver. The driver is the boss. It reads our code, understands the operations, and breaks the work into small parts like planning a task list, right? So this is what driver will do. It will read our code and divide the work. Step 3 is work is split into tasks. Based on the code, Spark creates a DAG. We will talk about it. DAG is nothing but you can think of a plan that we have to do this and then this and then this. That is known as DAG. Behind the scenes, it's just a fancy way of saying Spark figures out what needs to be done first, then second, and so on. Right? So that is your DAG. Then this DAG is split into stages, and then each stage contains multiple tasks. You will not understand this, but basically your work is divided into tasks, right? Driver will do that. Think of task as the smallest piece of work, right? So for now, you just understand that driver is splitting the work into multiple tasks for now, right? You will understand this later. And then executors do the actual work. Now the real work begins. We have two executors, right? Let's say we have two executors here in this example. We can have hundreds of executors in a cluster, right? Think of them as a worker machines. Each one has 4 CPU cores. So executor can run 4 tasks at the same time. So in total, we can run 8 tasks in parallel, right? So I was telling you number of cores. So this executor, let's say, has 4 cores, and this also has 4 cores, right? So total 8 tasks we can run in parallel, right? So this is what executor will do, right? So executor will do the work, right? Then results are collected, or if Spark has more tasks than cores, then it waits and runs them in next node. Let's say you have 20 tasks, but you can run only 8 tasks in parallel. So it will process 8 tasks first, then next 8, and then the remaining 4, right? So it will be like it will be kind of bus of 8, 8, 8, 8, 8, right? So it will just wait for those 8 tasks to finish, then next set of 8, right? If Spark has more tasks than cores, it waits and runs them in next node. Results are collected or written, right? Once the tasks are done, Spark either sends the final result back to driver, right? So in some of the case, these executors will send back result to driver, and then it will show you the result. Or there is a possibility that it will write the results output to a file or a database, right? So it will not send it back to the driver. So we'll learn all of those things. Okay, great. I think we can take it tomorrow, rest of the things. But since you understand this architecture, I just want to explain you how you can install Spark, right? Quickly, it will take 10 minutes. Okay, so what you have to do, I have created this repository Spark setup. I'll share the link. Let me share the link now as well. This chat box, let me stop sharing. Okay. This is the link. I will put this link in the my courses section as well, right? And let me start sharing again. Okay, so this is my GitHub repository, right? What you have to do, first of all, sorry, you have to go to this link, right? And you have to download the Docker, right? We'll discuss a little bit what is Docker. We don't have time today, but so that you do the setup, I'm just telling you. So this is your Docker, right? You will install as per what your system is, right? You can just check if it is Mac, Apple Silicon or Intel chip. Based on that, it is different. Again, for Windows, if it is AMD or ARM, you can check the settings of your system and you can figure out which one is yours, and you download that one and then you install. And you just have to install in your system and open this app. It will look like something like this. It will be empty for you. For me, it is showing something image and containers. We will understand tomorrow what is image and containers, right? But you understand this, right? That you have to download this, install this, and open this app, Docker Desktop, right? Then what you have to do, you get all of these files from. Let me go back. Yeah. So you have to create this folder structure in your system there, right? I'll show in my system as well, right? So let me show you in my system. You can create any place. I have created in desktop, and this folder name can be anything, not necessarily Spark setup, anything. Anywhere you can create in your system, right? And this setup works for Mac as well as Windows because I have done it in both, right? Same setup will work. Then here you have to create these folders, right? You have to create 5 folders: Jupyter, Spark Conf, notebooks, data, event logs, and there will be this Docker Compose file, right? I have mentioned here if you see. So you have this Docker compose.yml file, then you have Jupyter, and inside that there is a Docker file. So if you see Jupyter, inside that this is Docker file, right? So this Docker compose file is there. You can download it from here, or you can take a pull from GitHub, whatever you are comfortable with. Then you have to place this Docker file again within Jupyter. If you see, Docker file is there. So you get this and place it here, exactly how I have done, right? Then apart from that, that's it, right? And one more file you have is SparkConf, right? So inside SparkConf folder, you have this sparkdefaults.conf. So you have to keep all these files as it is, and you can download from the GitHub, right? Everything you can download, or you can pull this repository directly in your system, right? So you have to create this folder structure in your system, right? Simple. Install the Docker desktop, open it, create this folder structure. In data, we will keep all the files, right? So for example, you can keep orders.csv. I'll tell you how to create this file, right? Within a SparkCon folder, you have to create this file and put whatever is there, right? Once this is there, then for Windows, you have to go into the this PowerShell, right? And for Mac, you have the terminal, right? So now open Windows PowerShell or Mac terminal, right? And reach to that directory wherever you have installed it. So if I go here, right? So if you see, I'm into Spark setup in that folder. So you have to change directory and reach it there. Whatever you are, wherever you are, you have to change this directory. So for example, if I go cd dot dot, right? I'm on desktop, if you see, right? And within desktop, I have created this. So I will say Spark hyphen right? So once you are inside this folder, then you have to run some commands, right? Same commands for Windows as well as Spark app, Mac. So you have to run this Docker compose build, right? This will be only one-time command. So you will say Docker compose run, and you will just enter it, right? So it will create all your Docker image and everything, right? Then what you have to do, once this is done, you have to bring up all the services. Like we have the driver, Spark master, worker1, worker2, right? Whatever we discussed in the Spark architecture, right? So if you think about Spark, it is like you need multiple machines to work on a cluster, right? But we are just simulating it on single machine, but we have a different ports, right, where we can access them, right? So we will be working as a cluster, right? And we will allocate some memory. That for master, this is the memory, these many CPUs I'm giving. For worker, this is this, and this is CPU I'm giving. All of that is there in the two files, Docker file and the Docker compose file. All of those configurations are there. Right. So once you do this Docker compose build, after that you have to run this Docker compose up -d. So it will say all the services are up. Then on these ports in your system, you should be able to access it, right? So Jupyter Lab is where we will write our code, right? So let me show you how it will look like. So once you open this node, right? Let me close this, right? So this is my 8888 port. So once you open that port, you will see this screen. You can just come here and you can start writing the code, right? So for example, we said that we need a Spark session, right? So let me create a Spark session quickly. Okay, I can take it from there. That's fine. Okay. So let me take. Okay. So I'm saying from PySpark.sql import Spark session, and I'm saying this is my master, right? On port 7077, right? This is where my resource manager is basically, right? And this is my app name, get or create. And then if I run this, you will see that it will give me the Spark version. That my Spark version is 3.541. This is my master, and this is my app name. And then you can access the Spark UI and all. So you can try all these ports, right? Yeah. So once you run this, if you are able to do this, it means your Spark application is running all fine, right? This warning is fine. You can just ignore it. If you run it again, it won't come. So you can just ignore that warning. But this is what it is, right? If you want to, let's say, test something more that it is working fine or not, maybe you can run a small code. I'll just show you. So you can click on plus to add a new cell, or you can press B to add a new cell, right? Let's say I'm saying spark dot range 10, and then you will say show. Right? It's okay if you don't understand, but you will be able to see this state, something like this. It means it is all running fine, right? So this setup you have to do. right? It is very straightforward, right? Because it will work. It is irrespective of which machine, what is your configuration, because it is creating its own environment where it will install Python, Java, whatever it needs, right? We will little bit discuss about it tomorrow, what is Docker and how it works. But I hope you should be able to do this, right? So once all setup is done, you just have to run two commands: docker compose build from the folder where you placed all of this, then compose up, right? So your cluster will be up. If you want to stop the cluster, you just say docker compose down. Everything will be from terminal or Windows. So you will say docker compose down, your cluster will be down. Right? Then again, if you want to bring it up, you say docker compose up -d. Right? So it will be done. Right? And you can just test it by running this code. If this code is running, then you are good. Okay, great. So once you are able to do this and Spark is running in your system, you can just say Spark is running in Telegram so that everyone will get motivation, and I will also know that you guys have installed it. Okay. I think that is it for today. So tomorrow, what we will do, I will talk about this Spark setup more because I want to talk about what is Docker. At least I want to give you some idea. I mean, we are not learning Docker. You should have some idea what is Docker, right? And then we will continue with Spark, right? Okay, great. That is it for today. Let me know if you have any questions.
Hey Ankit, Richa here.
Yeah, Richa.
Just wanted to ask, what is the difference between Apache Spark and Apache Flink? Like, are they used for the same purpose or they are used like differently?
They have different purpose. I'll talk about maybe in some session what Flink does, but they are different.
So when you say Apache Spark is can be used for real time as well as batch processing.
Yeah.
So is it real time or is it near to real time?
No, so they have Spark streaming services. Spark has, right? So
Okay.
it can do real time processing.
Okay.
Yeah.
Thank you.
Yeah. Next.
Hi, Ankit.
Yeah, Subramanya. Go ahead.
A couple of quick questions. One is on the platform that we'll be using for Spark. Why not we use GCP Dataproc, right? It gives like we can set up a multi-node cluster on that and
You can do it.
close to real world experience.
This
Because
is also kind of real world experience, right? We have multiple executors, worker. You will get the real time experience here as well.
okay,
Yeah.
because
But
I
if you
believe
but if,
Databricks limits your this thing to only one node cluster.
no, so
Unlike
Databricks has so it's Databricks. If you see the new free edition, right? They have
okay,
the serverless Spark, so you don't have access to Spark UI and all, right? So you
right,
cannot learn on Databricks. Databricks you can use just to practice the PySpark code. But if you
right,
want to
right.
know the internals, Databricks will not work.
So we can use go for Dataproc if
Yeah, if you need. Otherwise, this Docker setup is also very easy. It will take 10-15 minutes. That's it. And it will be in your local system forever. You can do anything in future as well. It is very convenient, I feel.
right, right. And the second query is on the project, right? So will there be small projects in between or one comprehensive at the end of the course?
In between, I will give like for practicing this data frame API and all, I will give. And then in the end also, we will have one comprehensive.
So it mirrors real world
Yeah.
scenarios.
Yeah, so the last one will be like that, and the one we will give in middle will be a small project just for
What about
PySpark.
graded assignments and any project like for us to you'll give a sample data set and project which you'll evaluate at the end of the course?
Not evaluate. I will just give you the project. You have to do it, and I will also explain how to do it. I'll show you. But evaluation for each one of you will not be possible.
Okay, all right, all right. So, but I mean, if we send you an email, would you be willing to do that?
You can send it, but I am not sure if I can check everyone's project, right?
Okay.
Okay.
Okay,
I
all right. Yeah,
yeah.
that's it.
I just want
Thanks.
to say one more thing. So I have created a Python script. It is there in this folder itself. If you see, this is not part of your Spark setup. This is separate file, right? So if you see here, we have generate data.py. So this script you can use to generate data, right? So you can configure how many number of rows you need, right? So for example, 20 million data, you get 1 GB of data, right? So it will have all these column, order ID, customer ID, and all of that. So you can create different data sets for 300 MB, 1 GB, right? I'll show you in my system as well. So in data EUC, I have created orders 1 GB, 300 MB, and we'll use this data to understand some concept in Spark, right? So you can just download this script and you can run it in your system, and it will give you the orders file, and you can just put it into the data folder in your Spark setup. You have this data folder inside that, and we will see how we can read it tomorrow or later sessions. Okay, so this script will be very handy.
Sure, Ankit. Thanks for sharing this.
Yeah.
Ankit, am I audible?
Yeah, Prakash.
Yeah. So I have a question regarding when you said the data lake was introduced so that we don't put too much load on the RDBM system
Right.
while using Spark. Okay. So like, how does data lake resolve this issue? Can you explain that?
No, so you have this data lake, right?
Yeah.
I think there was another board. This one, right? So what I'm saying, let's say you have 10 Spark applications are running, right?
Yeah.
All of them will touch this database.
Correct.
So 10 times you are touching this.
Okay. Yeah.
Every time you fetch data, you are running a query and you are putting some load on the system, isn't it?
Yeah.
What we will do, we will just at the end of the day, once we will touch it and dump it into data lake.
Okay, we are dumping the data altogether. Okay.
And then 100 times, 1000 times you can read it from here.
Okay. So here I'm seeing app 1, app 2, app 3. So are these Spark session or what are these?
These are, you can say, different ETL pipelines.
ETL pipelines. Okay,
Data
understood.
pipelines.
Okay, okay.
Maybe in one pipeline, you are creating some customer analytics related data. Here,
Correct.
product analytics related. Here, something else, right? So you will
Okay.
have different data sets. As part of data engineering, you will be creating different data sets on which data scientist and data analyst can
Okay,
work,
understood.
right?
Yeah. One more question, Ankit. Earlier in the session, you said that the number of reducers will create different partition files.
Different files, output
Yeah.
files.
Okay. So like, do we like consolidate it before analyzing those? Like,
No, so typically what happens, it will create a folder. In that
okay.
folder, you will have two files if you have two reducer, let's say.
Okay.
Right? And when you are reading it, you can directly read both the files together. It is not like you have to read one by one.
And that is the recommended way.
Yeah.
Okay.
In Spark
Okay.
also same thing we will see.
Okay. Thank you, Ankit.
Yeah. Okay. Next.
Hey, hi, Ankit.
Yeah, Anshul.
Ankit, what is the difference between Spark, Databricks, Snowflake, and Azure Data Factory?
Okay. Okay, we'll take quickly this question. Okay, so maybe I should write in the notes only. Okay. So let's go here. I'll maybe write at the last. So you have Spark. Spark, you understand. It is a compute engine in memory, right?
Yeah.
This you have some idea today, right? And then it runs on a cluster, isn't it? And somehow you have to manage this cluster, right? Right?
Got it. Yeah.
Now, what Databricks has done, Databricks is like Spark, managed Spark, you can say. Managed Spark, right? Or you can say Spark on cloud, anything you can say. Now, you don't have to worry about cluster, where is the cluster, where is the machine. You just go to Databricks, right? You will say, okay, I need a cluster with 4 machines which have 16 cores and this much RAM. Then Databricks will manage it. You don't have to manage it. It will, whatever you will use, you have to pay for that. But resources as such, you don't have to manage, right? So it is a managed Spark Databricks. Apart from that, Databricks has done some optimization as well, right? So they are saying that on Databricks, your jobs will run faster, but ultimately they are running on Spark, but they have done some configuration things. And apart from that, they have given more features. So you have open source Spark. Spark is open source. On top of it, they have given more features like you can schedule jobs, Delta Lake. Delta Lake is part of anyway this now, but they have given more features, Databricks, that you can do a lot of other things on top of core Spark, right? So this is your Databricks. Now AWS, Azure, right? These are your cloud providers. Ultimately, what they do is they provide you the resources on rent, right? Cloud providers. So let's say you need a machine, EC2 machine, or you need a storage, right? You will go to AWS and say, okay, give me 10 TB of data I have, store it, I will pay for it, right? Or I need EC2 to run my Namaste SQL website and you have to pay for it monthly. Whatever you use, you pay for it, right? So these are renting resources on cloud, AWS, Azure, right? Now these companies have built systems also where you can run all of these workloads, data engineering workloads, like you have AWS Glue, right? You have Athena. So a lot of solutions they have also built, right? So you can do, so AWS Glue also runs on Spark only, right? So AWS Glue is a ETL solution from AWS, and in the backend it runs the Spark jobs only, right? So ultimately you can use Spark, I mean core Spark or Databricks, or you can do everything on AWS as well, right? It depends what your organization is doing, pricing, lot of things. Similarly, whatever AWS provides, similar kind of services we have in Azure as well, GCP as well, right? So all of this is there. Make sense?
Got it. Yeah.
Yeah.
And what about Snowflake?
Okay, so Snowflake is also kind of becoming a analytics platform,
Yeah.
right? So they started as a data warehouse first.
Yeah.
Now, what is data warehouse? Right. So now what happens? We understand that we have data lake. We are dumping all the data in data lake, right?
Got it. Yeah.
Now data lake has just raw data, right? We don't do any transformation, right? Whatever is coming from your transaction system, we just dump it, right? Now you want to give some structure to this data and do analytics, right? So what you will do, you will read data and you will create table as per your analytics requirement in Snowflake, right? So there will be some tables, orders table. They will be in different structure than your data lake files as per the requirement. And you done your analytics here now. All your analytics query, you connect your dashboard to Snowflake and do, right? So Snowflake is also kind of, I mean, competition to Databricks, right? The only thing is in Databricks, when you are running any load, it is running on Spark, right? Snowflake have their own different engine, right? It doesn't run Spark in the backend. It is very SQL heavy, so they have a different engine where they run.
Okay.
Okay, so this is how all of this is connected.
Okay. Okay. Thanks. Thank you.
Yeah, sure. Next.
Thank you.
Yeah,
Guru
Guru.
here.
Yeah, Guru.
During this map reduce, you explained sort and shuffle, right? So I just would like to know, like, suppose if you write some function, does system internally write its own logic, or as per our logic, the sort and shuffle? What exactly means shuffle? I didn't understand.
No, shuffle means the same key has to go on same machine, right?
Okay.
So when we are reducing, I want to make sure that all the fashion data goes to one reducer machine. Otherwise, I cannot give that result, right?
Okay.
So based on key, it will decide, okay, the key is category. So same value of category fashion should shuffle. This means it should go to a single system. From different system, it will go to and sit in single system, all the fashion records. Similarly, all the technology records, right? And let's say if we have two reducer, then maybe cloth related data is going here, furniture related data is going there. But one key cannot be available in two different reducer. Then it will be wrong, right? Got it?
Okay. Yeah, got it. So basically, this happens inside the blocks.
This happens over the network.
Okay.
So
Thank
they
you.
will write the data, mapper will write the data, this data. Then when the through network data is going, that time this shuffle will happen. And as per the key, the data will go to different reducers.
Okay.
Okay.
Thank you, Ankit.
Yeah. Okay. Next.
Hey, hi, Ankit.
Hmm.
So basically, you have told like a worker will divide the work into tasks.
Mm-hmm.
So like, will we learn about like how many tasks it is
Ha, ha,
allocating in
ha.
the
We will
backend,
learn everything. Don't worry. We have not even
data
started Spark.
internals of
Yeah.
Databricks
Everything we
and
will learn.
Spark?
You will just in first 2 weeks you will understand all those things and you will just love it. I'm telling you.
And one more thing, I think someone already asked like, how come? I mean, we can use Databricks as well for this learning and
Databricks
everything,
you can run to practice code. How you will
right?
run PySpark APIs practice you can do, but the Spark UI and all is not available in Databricks. Earlier there was community edition. In that Spark UI was available where you can see how data is flowing and everything, how many partitions are there, right? But in the free editions, they have the serverless cluster, right? And we don't have
Uh-huh.
access to Spark UI now. So that has become a bottleneck. Otherwise, I would have done on Databricks community only.
So that jobs and pipeline thing is not available now, I think.
These Spark UI basically is not available. But I'll show you how to create account and run code when we
Okay.
move to data frame API. If you want to practice on Databricks, it is absolutely fine. But to understand the architecture internals, we have to have our own setup in Docker.
Okay. Okay. Thanks. Okay.
Yeah. Okay, next.
Yeah, hi Ankit.
Yeah,
So
Miss.
I have two questions. So the
Mhm.
first one, queries regarding SDFS and the data lake. So
Hmm.
in SDFS, the data is stored in multiple machines. So when
Right.
Spark reads these data, so first how it will read? It will read the different files, consolidate it, and then again
No,
it will
no, no,
break it.
no, no.
Okay,
It will read from whatever files are available in that system only.
okay,
Yeah.
okay. So it will read all the files together.
No, so it will run in parallel. Let's say 4 machines are there,
Okay, okay.
right? So Spark is running on a cluster,
Yeah,
right?
yeah.
And then what it will do, whatever data is available on one machine, it will read in one machine and process it there itself.
Okay.
And then
So
second, and then third, and then fourth.
got
And
it,
then if
got
it
it.
has to combine, then it will do some shuffle there as well. We'll see.
Okay. Okay. But then don't you think SDFS has this advantage of
Mhm.
storing big files into small chunks and Spark directly can take that small chunks and the processing becomes faster. But in case of S3, the
Mm.
whole 20 GB file is present in one chunk that Spark will read in one chunk and then it has to distribute further split that file, I think, into multiple chunks and to distribute against multiple executors, right?
Yeah, but we see there are a lot of other problems. Maybe there is some performance benefit with SDFS, but not significant compared to
Oh,
what
okay,
disadvantage it has, right?
okay, okay. Got it, got it. The second question, Ankit, is regarding the installation. Okay, so you
Hmm.
said we will work on this notebook. So can I work on some IDE, some VS Code or something also?
You can work it. I have not tried it, but I think with Jupyter Notebook, it is very interactive,
Okay,
right? You run some code, see the results there. It is easy to explain also. And when you practice, you can see step by step.
okay. Yeah,
If you are
got it,
doing
got it.
in VS Code, it is like you will write full code and submit it,
Yeah, correct.
right? So you will not see step by step.
Hmm.
Okay. We'll later see that how you will do it using Spark Submit. So you can create a Python file where you have
Yeah,
all the
yeah.
code and you will use Spark Submit to send that code to Spark cluster and it will execute and return the result. We will see later.
But can we have at least one session how to use the same in some ID? Because in real case scenarios, Ankit, we usually use IDs to run all these codes and everything, right?
I can check that and do it. But mostly I'll tell you in Databricks also everyone works on notebooks now, right? You can directly schedule the notebooks in Databricks and mostly people works on notebooks. But yeah, in ID also we can do setup.
Yeah. Okay. Thanks, Ankit. That's all.
Yeah. Okay.
Hi,
Anyone?
Ankit.
Yeah, Ravi.
Yeah. So, Ankit, I want to understand like for optimizations, when we will read about optimizations, will it be like mimicking the real world problems? Because I have gone to many blogs and even several YouTube videos, but what they teach is like, it's like, I mean, to say that it's a bookish language they always use. Like, what are the optimizations? Everyone says that we can use salting and
We will
we
see
can use.
everything practically. We will not just talk theory. Everything I will discuss. We will see practically in systems. We will run the job, see the problem, and then solve it.
So we will be mimicking
Yes,
some scenarios as well.
absolutely.
Okay. And apart from that, I want to understand, like I'm not from the tech background, but I want to understand, as you were giving the example, so we can take example of Namaste SQL only. When I reach the portal and I have purchased your course, fine. So
Yeah.
I want to, so you must be using some CRM or some sort of thing to check what is the traffic on your website. And if I'm purchasing your course, so there must be some my data you will be capturing. You must be
Right.
capturing my data. So
Right.
I want to understand, but I mean, how my data is being captured by you. I mean, is it some APIs working?
Yes. Yes. So there
How
will be a
that things work?
front-end APIs will be there, right? So what happens when you purchase something, right? Those API will send that information to MySQL, okay, in terms of JSON, okay? You purchase will be sent back to the backend, and in backend there will be some programs, PL SQL code, which will store that data into MySQL tables, basically, right? Once it is stored, then it can be read again. Like if you go to my courses, you will see how many courses you have bought, or your transactions, or your profile, everything you can see, right? So when you create your profile or sign up, right? When you sign up, there will be some data going from front end to back end, and it will be stored. And it will be read back whenever you see some information. Okay.
Okay, but and there is, if I talk about the connection between Namaste SQL app and that's MySQL, there's some APIs are running to
Right. Exactly. Which will do the authentication and all. Yeah.
Okay, so it is a universal process.
Yeah, it is a universal process. This is how it happens.
Okay, so even if I go to some Reliance store and they capture my data, so when they that data will be posted via API into their database.
Exactly.
Okay, cool. Thank you.
Yeah. But this work is
Yeah,
not
hi.
done by data engineers and all. This work is done by SDs, software developers. Just want to tell you. Yeah. Go ahead.
Yeah, hi, Ankit. Shekhar this
Yes.
side.
Yeah, Shekhar.
Yeah, Ankit, just a silly question. I can see there is a lot of this mapper and reducer where you have taught us the sort and shuffle. Can you bring to that dashboard? So there is confusion where this sort and shuffling is happening. What
This
I
is
understand, shuffling means you are moving the data from one system to another system.
Right.
That means it must be happening once the sort is done, when the fashion is brought into a single frame, then only the shuffling must be happening, moving the data from machine X to machine Y. So both should
No,
happen in reducer.
first shuffling will happen. Okay. And then sort. It is ulta. Okay.
Okay,
So how it
it is
will
reverse.
happen? So first shuffling will happen. Shuffling means it will make sure all the fashion comes into one machine, right? So let me take this. So during shuffling, let me take one more here, right? So during shuffling, this fashion will come here. Sorry. Let's say fashion, right? And let's say fashion and technologies are coming, let's say, right? In reducer one, right? So you will have technology, fashion like this. Technology, then fashion, right? And again, you will have, let's say, technology, fashion. This is how it is, isn't it?
Okay.
So these two keys are coming on this machine, right?
Mm.
You understand this?
But ideally, it is a sorting, right? Shuffling means you're bringing the on the what basis this shuffling will happen. Technology is a key, and fashion is a
So
key,
all the
right?
technology should go to one machine. All the fashion should go to one machine. Based on that, shuffling is happening. All the clothes will come to here. All the furnitures will come to here. This is shuffling.
Correct.
Once
So
shuffling is done, then sorting will
Mhm.
be done so that all the technologies are together and all the fashions are together, right?
So in a nutshell, Ankit. So actually, what we're saying is shuffling at a back end. Actually, the sort is happening, right? How does it will come to net that okay, technical all the technologies should come into one place.
Because it is the same value, na? So it will have some mechanism to identify these two are same value. No,
Okay.
no.
Let me rephrase this question another way. Suppose there are two technology words and there are three fashion words, right?
Mm-hmm.
So all were distributed in the map phase. It is in a two different box. When
Right.
we do a sort on the first field,
First shuffle will happen. First shuffle will happen.
yes. So here is the point here, pain point. When we say shuffling,
Hmm.
shuffling just means a literal meaning is moving the data. Now
Moving the
what we
data
understand.
from mapper to reducer, but at the same time, it will make sure that same key is going on the same reducer. So if technology is there, all the keys of technology, all the records of technology should go to the same machine, not two different machine. All the values
Okay.
of clause should go to reducer 2. And after that, it will do sorting and bring in this stage all the data.
I think I'm getting a point, but it's still not convincing why I'm saying. Because when you're saying shuffling, how it will know that the technology of second is going to technology one? So it's a kind of sort, right?
No, no, no. So it is a value. It will create a hash value of it, let's say. Right? Let's say hash value of technology is something 1, 2, 3. Right? So it will know
Mhm.
either this machine or this machine. Wherever this hash value is coming, right? It has to go to one reducer only.
Okay. So you're saying it creates some hash value and the same hash value is pushed into a single machine.
Reducer.
That's
Right.
okay. So that means shuffling and sort both are the job of reducer.
Shuffling is happening over the network.
Okay.
So once data is read from here, over the network, shuffling will happen and data will reach to reducer. Once it is reached to reducer, then sorting and aggregation, everything will happen.
Okay. No, I can see in the chat, Nachiket, the person he has written, the shuffling is happening in the mapper. Hence, my question is raised.
No, shuffling is on the way, over
After
the
mapper.
network. It is over the network. It is not happening in map or reducer. It is over the network. When the data will be read from here and when it go to
Mhm.
the reducer, right? In that process, it will happen shuffling.
Okay.
So
So can
shuffling
I
is
say
over the
shuffling?
network. It is network heavy shuffling.
Okay. So can I say shuffling is post mapper and
Right.
sorting is within the reducer?
Right. You can say that.
Okay. Perfect. Thank you.
Yeah. Okay. Next. Anyone else? Or we are done?
Hi, Ankit.
Yeah, Adoy.
Yeah, so just a question regarding a prerequisite. So it's mentioned that Python is needed. So how comfortable should we be in that to
Uh,
do the course? Yeah.
I'll tell you, we will learn something called as RDD, right? Now, RDD is a low-level API,
Mhm.
right? RDD. It's a low-level API, and you should understand what is RDD, right? But you don't need to learn that how to transform data using RDD, right? That is not required, right? But we will just basic learn some transformations so that you will have some idea and you will have idea that why there are higher level API, PySpark and Spark SQL, right? So when we are working with RDD, we need some understanding like what is list, what is dictionary, tuple, right? These things you should know, right? What is maybe loop, at least these things. Apart from that, when we are learning data frame API, right, we'll spend a lot of time. For this, there's no requirement, but if you have worked on pandas, then you will find it very similar. But it is not a prerequisite. I'm just telling if you know pandas, you will find it very similar to pandas. If you have not worked it, that's fine. You will learn from scratch data frame API. But basic variables, list, dictionary, tuple, loop, you should know. I mean,
Okay.
if you are into data engineering without Python, you cannot survive. So you have to learn anyway. So learn now.
Yeah, makes sense.
Yeah.
So I'm just aware about the basics, but the other part, that is the pandas, I don't use it much, so that's why I
That's
just
fine.
wanted to
That's
confirm.
absolutely fine. If core Python, you know, functions and all,
Mhm.
that is more than enough. Maybe I will add functions as well here. Okay.
Sure,
Great.
yeah, that answers my question.
Yeah.
Thank you.
Next.
Hi, Ankit. Can you hear me?
Yeah, Gopi.
Ankit, I'm not a data engineer, but I'm learning online. After this course, how would we position to which profile we need to position ourselves?
So you should know SQL, Python, and Spark, bare minimum, right? Obviously, you
Yeah.
should know data modeling and data warehousing thing,
Mhm.
right? So you can apply for data engineering jobs which require this, right? In data engineering, there are a lot of tech stack, right? Someone is hiring for Snowflake, someone is hiring AWS data engineer, right? Someone is hiring Kafka developers. But whatever job requires, a lot of data engineering jobs is required this, right? And once you learn this, Spark, right? After that, you can easily learn Databricks as well. And Databricks is in a lot of demand. So I will highly suggest you after this, you learn Databricks and then you will have a lot of opportunities.
Mhm.
Okay. But to learn Databricks, first you should know Spark
Okay.
because it runs on Spark ultimately, Databricks.
Okay. Databricks internally uses Spark.
Yeah, it is managed Spark, as I said. Right? Yeah.
Yeah. Okay. After learning this course, then I need to learn Databricks. That's what.
Yeah. I mean, jobs you can start applying if you know these things, right? But you can parallelly start learning Databricks.
Okay. Okay. And any projects from this course that can
Yeah, we
help
will do a
me?
project on Spark. So we'll do. Yeah.
And you mentioned about Spark UI that won't be available in community free edition of Databricks. So
Right.
that's only available in Azure Databricks or some cloud
The
Databricks.
paid version. If you take the paid version, in that it is available. In free, it is not.
Okay. Okay.
Okay. So I would highly suggest you do the Docker setup.
Okay.
Yeah.
Yeah. And the notebooks you're showing, the visualization boards will be also shared in the materials
Yeah,
also.
yeah. I will just put it in the notes itself, this Notion notes, and then I'll take out the PDF and share.
Okay. And one last question, we cannot position ourselves as a Spark developer or something like, right?
Yeah, you can do
Only
it.
with this.
When you say Spark developer, it is data engineer only, right? Spark is data engineering only. There's no other role in Spark as such.
Okay, it's data engineering.
Huh. Spark means data engineering. There's no other use case of Spark. Data engineering, for data engineering only it is used. That's it.
Okay, got it.
Yeah.
Yeah, thank you, Ankit. Thanks for answering.
Yeah.
Hello, Ankit.
Yeah, Ankur.
So, Ankit, each executor is a compute-only machine, right?
Each executor is the compute only. It will have disk also. Sometimes
Okay.
data will spilled into disk. We'll discuss that. Obviously, it will have disk. Any system will not just have CPU. It will have some disk also, right?
So like disk as in RAM, memory.
No, disk is hardware.
Okay.
When I say disk, it is hard disk. Sorry, hard disk.
Okay.
Right? When I say RAM, then it is memory. Compute is RAM plus CPU. Right? When I say
Right.
compute, it is RAM plus your CPU.
So
They
it's
will be compute heavy machines, you can say, executors.
so these are like fixed cost, hardware, fixed hardware. That
Yeah.
is
Yeah.
okay. And one has to like instead of setting up the hardware locally, they can buy the hardware from other companies.
From
Like
AWS and all you can
servers
take.
and all. Okay.
Yes, yes.
Okay. And so like we can like Spark is so from my understanding, like Spark is used for processing big data,
Right.
and then we like after we process the big data, we can use Snowflake to do analytics from
You can do that.
yeah. So
Yeah, you can do
Snowflake
that.
on top of Spark.
Yes. So what you will do basically, you will process your data using Spark.
Yes.
Then you can store it in S3 maybe.
Right.
And then on top of it
From
in
S3.
Snowflake you can.
Okay. Okay.
You can do anything. Within Spark also you can write interactive queries, build dashboards.
Okay.
So yeah, many companies use this combination, whatever works for them.
Mm-hmm. Okay.
Yeah.
And like uh, we are in, I didn't understand what like why or what we are installing. Like in Snowflake, we didn't install anything. It's all
Yeah.
on UI. Everything was
Yes.
on browser or
Yeah.
cloud.
Yeah.
But then, like, what or why are we installing Spark?
So Spark is a open source technology. It is not a platform like Snowflake.
Okay.
It's an open source technology. If you want to use it, you have to install it and run it, right?
Okay.
Now that's where Databricks come into picture, right?
Okay.
Databricks is a managed Spark, so you can just create an account on Databricks just like you create on Snowflake,
Hmm.
and you can start running your Spark jobs there.
Okay. Okay.
But the only thing is, in the free edition, you don't have access to Spark UI. If you
Okay.
can buy paid edition where you will have to pay, then you
Uh-huh.
can create cluster there and do everything, see the UI, everything.
Okay.
So to avoid that cost, we are setting it up locally.
So basically, we are setting up we are imitating a cluster environment where we
Right.
have okay.
In our machine, exactly.
Okay. So any idea like how much space is required to set up Spark?
So typically, if you see the configuration, let me show you. Maybe I missed it. I'll show it to everyone. So let me open this file quickly. Open with text edit. So we have created executors, master, and everything, right? So if you
Right.
see, these are the two
Workers.
containers, right? And what we have given them two codes and 2 GB RAM. If you feel your system doesn't have this much, maybe you can give 1 GB RAM.
Okay.
Or if you have more, you can give more.
Okay.
So this will be allocated for master one. Oh, sorry, worker one. Similarly for worker two,
Okay.
right? And apart from that, we have the driver which is running on Jupyter Notebook only. And for that also we have 2 GB. Okay.
2
So
GB
you
of
can
RAM.
change this configuration if you feel your system cannot handle this much.
Okay.
you can change this configuration, which is absolutely fine. It is just that your jobs will run little slow
Okay.
and mine will run little fast. That's the
And
only.
all this RAM will only be used when we are using Spark, and
Yeah,
otherwise it won't be
right,
used. Okay.
right.
Okay. Okay. And one last question, Ankit. Like we work on APIs. Like I know, like API, we get response from API which is in
Mhm.
JSON, and then we
Hmm.
do manipulation with data. But my understanding has always been abstract. Like what exactly is an API? I know it's a like with API we can communicate between two software machines.
Hmm.
But
So there are two things, right? One is that API that you are talking about. Let's say I have some data. I want to get, let's say, Zomato data. They have provided a API. So what API will do, it will go to Zomato system and get the data, right?
right.
So you have to do some authentication and all. So it will hit their database, or maybe they have some data lake they have created. So that API, that code, let's say Python code, will go
Okay.
there and get the data for you. That is one type of API.
Okay.
Another, we are talking about the data frame APIs, right?
Okay.
And you will understand in tomorrow, like we have low level APIs and high level APIs, right? Low level APIs are like RDD, right? You work with the very basic unit of data, RDD. But it is not easy to work with RDD because they don't have a structure. They are just like the objects in memory. They don't have a tabular structure and all,
Okay.
right? So they have created a higher level API on that, PySpark API. What it does, you write your code in PySpark only
Okay.
using Python or
Uh-huh.
SQL, but internally it will be converted into RDD code and execute in Spark.
Okay.
Right. So this is a different way of different definition of API basically.
Okay. So in reality, API is like it's a block of code only that is doing all
Yeah,
these transformations and
exactly.
okay. 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 Yeah. Thank you.
Yeah.
Thank you.
Yeah, Guru.
This executor internally is referring to the CPU or RAM? How I can understand?
Both. So as you say, this is a Spark Worker one, right?
Yeah.
So we have one executor here. We can create multiple executor as well. We'll discuss later. But
Okay.
imagine for now in each worker we have one executor, right?
Okay.
And for
Okay.
that executor we will have 2 GB memory and 2 cores of CPU.
Okay. Basically, you mean say worker node and execute. Okay, it will be same.
Worker and executor for now you understand same, but they are different. In one
Okay.
worker we can have multiple executors.
One
Okay.
worker. Okay. Okay.
Okay. So
Yeah.
we'll discuss later. Don't get
Yeah.
confused
Yeah.
now.
Yeah. Yeah. And one more thing. Suppose if I want to put my full-fledged resume, I heard like we need to put PySpark and one schedule orchestrator.
Mhm.
And do we need to go for data warehousing also putting in resume? How exactly it will come with a full stack resume? Can you suggest which tools we can put it in resume?
See, as I said, you should know SQL, Python, Spark. These are the
Ah,
things.
those
Apart
are
from that,
clear.
you should also know data modeling, data warehousing. These are basic things. Doesn't matter you work with Spark, Snowflake, AWS. Data modeling and data warehousing basics, right? What is a normalization? What is star schema, Snowflake schema, fact, dimension table, slowly changing dimension? These are basic things every data engineer should know, irrespective of technology.
Okay.
Right. So learn those things. SQL, Python, data modeling, data warehousing is like a base for data engineer. On top of it, you learn more things. Right. So
Correct.
SQL,
If I
Python,
want,
data modeling, data warehousing, and then you learn Spark, AWS, whatever you want to learn.
this part is clear to me. Thanks for that.
Yeah.
Suppose if I want to put some orchestrator, should I put Airflow or should I put ADF? Or should I put both? That way I'm asking like
You learn one and put that. That's it.
one. Okay.
Yeah.
Any one of that, right?
Any one you learn and just put it on the resume. That's it.
Okay. Sure, sure. And will you be covering only PySpark or I'm just asking like for information. Will you be covering any scheduler, how it is?
No, scheduler is not part of this. This is just a Spark. Yeah.
Okay, sure, sure, sure. And suppose if I want to take other courses, like do we get any coupons? I mean, just
So
asking.
coupons for individual courses are available on the website checkout page.
Checkout page. Okay.
Yeah. When you reach checkout, you will see a banner that you can use this coupon. Okay.
Okay.
For combos, there are no coupon because combos we have already kept at lower price.
Okay.
But for other individual courses, there will be coupons at the checkout page.
Okay. Thank you, Ankit. Happy.
Hi, Ankit.
Yeah, Akshay.
So like you said, you need data modeling and data warehousing. So for that, do you have any suggestions where we could learn that?
You can learn at Namaste SQL if you ask me.
Yeah, no, I mean, yeah, definitely for that
But
would
there are
be.
a lot of resources you can learn anywhere. Matlab, these are old concept. When we were in, I started in 2010, my career. That time also we used to learn these things, data modeling, data warehousing. So they are there
Yes.
for years, right? You will find hundreds of resources on YouTube, Udemy, any website, Namaste SQL. So you can find it yourself, right?
Sure. No, like I had learned, like my first experience with SQL was in 2017. That's when I started my career and everything.
Yeah.
So in that, like I had done data modeling and but not data warehousing. So I mean, like how do we show to like prospective employers like we know data modeling and like we know
Do some
what.
project, put it on GitHub. That's the only way, right?
Okay. Yeah, in this course, if you can like while doing a project, if you can show like how to put like on GitHub and everything, that would be also
I'll
great.
show you. I'll show you. Yeah.
Okay.
I just telling it is part of analytics engineering bootcamp. I think some of you have done this already. In that we have in detail data modeling, data warehousing, Snowflake, right? If you want to do it. But if you want, it is part of Snowflake bootcamp as well. We don't have an individual module because we want to do some hands-on also once we have data modeling, data warehousing. So it is tied with other modules.
Yeah, I
Right.
was actually planning to get the analytics engineering bootcamp, but in that I've already done some things like Power BI, SQL. I already know, so I just wanted to learn about data modeling, warehousing,
Maybe you
and
can take
Snowflake.
Snowflake one. You will also learn
Okay.
Snowflake in that process. Yeah.
Okay. Okay. Yeah, that one is there. Okay. Yeah. Yeah. Sure. Yeah.
Okay.
Thanks.
Yeah. Next.
Yeah, hi Ankit, Achin
Yeah,
this side.
Chin.
Yeah,
Yeah.
yeah. So like Ankit, I have a question. Like I also started my career like the same time you did, like in 2010. So like my question is like I have as I have like experience is not like 10 plus years of experience. So what you would suggest like do we need to like after doing this do we need to do system design as well? Like that is also required when we like go into like job search or like what that is also a requirement for like experienced guys.
So system design somewhere comes from the data modeling and data warehousing, right?
Okay.
It is not something completely different thing, right? How you will design systems, right? How your tables will be, or how your architecture will be, right? So it is system design is like if you have 10-15 years of experience, right? You would have done a lot of projects already, right? So if you know the architecture of those projects, you can relate how different projects have different architecture, right? How they serve the purpose. That is all is system design, right? It is not some
Okay.
different technology you have to learn for system design. It is just a concept that how you will design your system, what will be where you will keep your data. Maybe in S3 you will keep the data, then you will have processing somewhere, and then how will design your tables. So all of that comes into system design.
Okay, that means the complete architecture design from
Right.
like whenever we start with like a scratch for application or
Right.
so then okay, and just like last year I took your like Python course and like using that I like created some like database reports. Like I'm mainly into cloud and database.
Okay.
So I like use pandas and created some database reports as per client requirement for the like GCP patch databases, mainly SQL and Postgres. So that was like really helpful for me. So I thought, why not to proceed with Spark, that
Absolutely.
India.
Spark is in lot of Spark is in lot of demand, right? Especially Databricks, right? So once you learn Spark, then your gate is open to learn Databricks automatically, right? So that once you learn Spark and then Databricks, now there are a lot of job requirements nowadays. So just 3 4 months of focus you have to do, then you will have ample opportunities.
Yeah. Okay. Thanks. Thanks, Ankit.
Yeah. Okay, we are
Hi.
done. Okay, yeah, Kumar.
Ankit, like my question was on Databricks only because we are learning Spark right now.
Mm-hmm.
Do we also cover in this course the concept for this delta tables, Unity catalog, this kind of?
So Unity catalog is specific to Databricks. We are not going to cover,
Okay.
but we have delta tables, right? There's a part of now open source Spark.
Yes.
So that we will cover.
Okay, so like for these ACID transactions.
Yes.
Okay, Ankit. And any real-time scenario like streaming processing or something like that we will
No,
cover.
streaming we are not doing. Streaming is a different big topic altogether.
Okay.
Right. So I'll say focus on this first, right? Streaming. If you have 10 jobs, I think 8 or 9 jobs will be for batch processing, 1 or 2 jobs will be for streaming, right?
Right.
So I would say focus on batch processing first. Once you are good, then you can learn streaming later.
Okay, and how about this? Like we will be covering PySpark as I understood.
Yeah.
How about Spark SQL? Because when
Yeah,
we
yeah.
will migrate from here to there, then we will have stored procedure functions like in RDBMS databases, right?
Mhm.
And these temporary tables on Spark SQL would be easy to migrate, right? Easily.
So Spark SQL, I don't think you can write procedure and all. That Databricks has now enabled it, but in open source Spark, you can write SQL queries,
Yeah.
but I don't think you can run procedures and all.
Okay. Like we have to create these UDF, right? User defined function.
UDFs you will have to create.
Okay.
Yeah.
Okay, that's it. Yeah. Thank you.
Okay.
Yeah, hi Ankit.
Yeah.
Yeah, I'm into data analytics right now. So I have some 7+ years of experience. I mean,
Mhm.
after learning this, how many years I can showcase and how the questions will be there in Spark. Can you please elaborate on this?
Maybe we can take at the end. Now I will tell you what kind of question you will not understand. Once you know Spark, then I can tell you what kind of questions they will ask, right?
Okay,
Maybe we'll
and
discuss later.
okay, for experience related,
So experience, what you can do is, let's say you have 7 years, you said, right? Total
yeah,
experience. Maybe
yes,
you can show 2 years of experience into Spark, and what you can do, whatever projects you have done, you can
okay.
just write it on your resume that you have done on Spark, and accordingly you
Mm-hmm.
should be able to explain it as well, right?
Okay, okay.
Yeah.
How we can bridge between this analysis because my designation is written as analytics. So how
Okay.
we can bridge this data engineering with this data analyst?
So you will have to little bit go back. So you are working as a data analyst currently, right? You are working as a data analyst or data engineer? Hello, am I audible, Nachiket?
Oh, yes, you are the buyer's muted. One
Okay.
Mute, sorry.
minute.
Yeah. So what I'm saying, you are working as a data analyst, right? I think some
Yeah,
internet.
I'm unable to unmute. Sorry. Yes, a data analyst.
Okay. So you basically run queries or create dashboards.
Yes.
Yeah. So little bit you will have to, if you don't know Python, you will have to learn Python, as I said. You will have to learn data modeling, data warehousing. So basically, whatever tables you are consuming, right? As a
Okay.
data engineer, your work is to manage those tables,
Mm-hmm.
right? So you will have to learn all of those things, that how tables should be created, how they should be there in your data warehouse, right? And how you will automate all the pipelines, how you can use Python, right? So little bit
Okay.
more you will have to learn. But how to transform data, you will learn in Spark. Using Spark, how you can process the data, right? As I
Okay.
said, you have data in your OLTP systems and you want to
Mm-hmm.
convert it into some other structure and then write it back somewhere else. So whatever in
Okay.
between transformations you have to
Mm-hmm.
do, that we will learn
Mm-hmm.
how we can do using Spark.
Okay.
And yeah.
Okay, thank you.
Okay, Anand, I think last.
Hey, hi, Ankit.
Yeah, Anand.
So, Ankit, recently I just gave an interview. It's maybe regarding a optimization question. So, can I ask this?
Optimization of what?
There was a question asked. Every day I was getting a 50 GB data, okay,
Mm-hmm.
and suddenly the data volume size got increased to 500 GB.
Mm-hmm.
So, how you will optimize?
Spark job or what it is?
Yeah, Spark.
So then you will have to again learn Spark first, right? So maybe you can ask this question once we are at the end of the course. Now, if I explain, you will not understand only.
Okay.
You should know Spark to do optimization. Optimization is second thing. First, you should know Spark, right?
Okay.
Even if you know, I don't want to answer it now because for other people, they will not understand.
Got it. Thank you.
Yeah. Okay. Okay, great. Thank you, everyone. We'll meet tomorrow and I'll upload the recording in around 2 hours. Please set up the Docker and let me know in the Telegram group once you install it and everything is fine. Okay, that is very important to set up your Spark. Otherwise, you will struggle to learn it. Okay. Thank you, everyone. Have a good day.
Recording stopped.